done this morning session on the ROS. We have just divided into three parts. So I will be just giving you a short brief about the ROS, the fundamentals of the ROS. Certainly, we don't have enough time to dwell deep into the ROS part. Certainly look forward that we can conduct a dedicated session on the ROS. So today we'll be just trying to give you a quick glimpse of that, what exactly it is, why it is to be used, what is the basic framework of operation. And then I will request Kalahar after me to give you a quick demonstration on the implementation part. And post that we have a session on the ROS and MATLAB interface. So that is how we plan the first 2 hours of the activity. And then we'll take forward for the presentation part. Let me just share my slide. Yeah. Okay. So certainly, as I was telling, that it's really a very interesting topic to learn and the subject to learn when those who are really looking forward to work in the domain of the robotics. The idea behind ROS is basically to facilitate all the developers, all the enthusiasts to build the robotic application as quickly as possible. Right? So if you look at normally when we talk about the ROS, this is just a one part of the curriculum that I used to cover in one of our course. We need to understand these are the basic things we should know actually about the ROS. So I'm not going to cover all, but I will be just touching upon the initial fundamental things. So introduction to the ROS, the framework. Some of these things have been changed also because I will be discussing the concept which are in the ROS 1. Last 2 years, I think the ROS 2 is now coming up, making ROS 1 obsolete after 2025. So we are still in a phase of learning ROS 2. So that this is just what I'm going to explain is applicable to the ROS 1. So we need to understand the workspace, the framework, topics, messages, and then we will be understanding some other tools for the visualization, how you will control the robots with the teleop, how you will generate the map, how you will be storing the data using ROSBEX. Then there is a navigation, how you will make the autonomous robot moving using the ROS, the way I was just demonstrating to you. The various methods of building a perception and then behavior part that you can use. Even you can integrate the OpenCV into the ROS also. Certain applications you can do using the vision itself. So line detection, following the line, all can be done with the help of a camera here. And then you can also build your ROS bot. That is the important part. So certainly what we are trying to do last 2 days, we can also write the ROS framework for this customized robot. So bring your own sensors, actuators, mobile platform in the ROS. So that's a whole idea. Those who would like to start learning on the ROS, they should at least go through these basic libraries or the tutorials which are already available on the ROS wiki. So when we say ROS, though the term says operating system, but it's not an operating system in the true sense. It's basically a framework for the robot software development. So it will be running on other operating system. Ubuntu is the most common one that we are using for running ROS. But the ROS 2 is now more supported on other platforms as well. So you will be able to run ROS 2 on the Windows as well. Linux, you will be anyway running that. So that's not a problem. And good thing is that it can also be made to run on the embedded platforms. So maybe Raspberry Pi, you can run the ROS. We can run the ROS on the Jetson also. So if you understand that it's a collection of the libraries basically and the tools that will help you in accomplishing the complex tasks of the robot control, how you will do the robot behavior understanding, perception part, control of the robot platform. Idea is that the robotics is such a big field that each one of us, if they start from the scratch, it will take a lot of time. So this open source project has been started in the direction that it will help people to build up their robots much faster. That's how it's in a collaborative robotic software development. So people contributed from various parts of the world. They created those libraries. So for example, as a mechanical engineer, I want to build a robot, or if I just build an autonomous car, how quickly I can do that. If I just start learning algorithms, writing algorithms on my own, it's a basic code that you keep writing, then it is going to take a lot of time actually. That's the reason that people come together to build this take this initiative to build the complete framework for the implementation and development of the robots. So if you see this operating system, that ROS is having all these unique features, that it has complete device drivers, inter-process management, communications, it is taking care of. It has a complete suite of tools that will be helping you in visualizing, simulating while you are developing the application. So it has a very nice UI available. You can log the data, which will also be played back as in a real-time data. It has a capabilities of control the robots, planning, perception, mapping, manipulation. So complete functionality applicable for the various robots, various type of robots also. And the good thing is that a good ecosystem that is being developed as a part of this. So all packages are nicely organized. They are distributed through the open source, so you can easily access them. It's a very good documentation available on the ROS, so that learning will be much faster. A lot of tutorials are available, guided tutorials are available. So there's a lot of activity around the ROS, and that's how people are learning, those who would like to implement the complex robotic systems. I just want to take you through a quick brief on the ROS, though it is little older, but it's still relevant. It has been developed as a open source initiative in 2013. Initially, it started in 2007 as a part of the Stanford Artificial Intelligence Laboratory. Later on, the Open Source Research Foundation took it on 2013. And most of the universities, campuses, and the companies, in fact, the ROS Industrial, now it's coming to the industry as well. So people are using all across the world. So initially, ROS started from the as an academic project in the universities, and later the people start using it for the research, and then there's enough confidence built up on the ROS that people now start using in the industries as well. Just running this quick video for your understanding. So idea is to give you a quick glance on the kind of academic projects people have done on the ROS and the type of robots. You might have seen that whether it's an underwater, it's a ground robot, or the aerial robotics, whether it's a driverless car, or it will be an industrial robot, articulated robot. So you find that they have implemented on various type of robots. That's a way that ROS has grown in the last 15 years, basically. So the core philosophy of the ROS, which makes it quite comfortable and people love to work on the ROS, is that you will be able to communicate between the various applications. So individual programs can communicate using the ROS messages or the services. So there are APIs available through which you can make the different programs communicating. So that makes the distributed basically. So your application may not be just running on one hardware or one system. You can make it to run on a multiple network of the computers. That's the advantage, that because when we go for a complex robotics implementation, certainly you look forward, there would be a main computer. There are a few embedded computers around it. So you can do some processing on the Raspberry Pi, some processing you can do on the Jetson, and some processing you can do on the industrial PC. That's how people are combining the various hardware to run the processing. For example, if it is too compute intensive on one single platform, it will be reducing the speed of the operation. So if I would like to implement the vision, I will be putting it on the NVIDIA Jetson, and then it will be dedicatedly processing the vision part, and then will be sharing the outcome through the messages. So that's the advantage, that you have a communication established between the various hardware, and the distributed processing can be done. Another advantage of this is the multilingual. Actually, it's not limiting people to C, C++, Python, or some other languages. You can write the ROS nodes in any of the languages. In fact, the good thing is that in one single project, everybody is writing their nodes in a different programming environment, and still they are able to communicate. So it's a very good framework for working in a team, actually. So someone write a program or a node in the C++, I will be writing my node in Python. Still, I will be able to make both the nodes running into the ROS, in the same ROS environment. So that's how the MATLAB is also gaining a good traction over here. They are able, so you can do some dedicated processing on the MATLAB using their libraries, and then finally connect with the ROS in ROS master, and you can share the messages with the other ROS applications. So that's an advantage here, that it's not limiting people to write everything into one language. It's very lightweight, as I was saying. You can even run the ROS into the very basic Raspberry Pi also, even with the 2 GB RAM. So that is also able to run it. So many embedded platforms are able to run the ROS. So that's how it is not that heavy, that any operating system can run it, and in a very limited hardware resources, you will be able to run the ROS. And the most important is certainly the free and open source. That's how the development happens so fast, and it's available for free. So that's an advantage, that people are looking forward to work in the ROS. You'll get all the information on this website, the wiki.ros.org, starting from the basic installation, getting started tutorials, and then slowly, once you do the basic understanding, then you can go and implement on any of the hardware further. So most important part, if you understand over here how it works, basically, if you see at the core, at the bottom layer, you will be having a hardware. So any hardware on which you would like to deploy the ROS, or using ROS which you want to control. So it can be on a four-wheel kind of a vehicle. It can be on a differential drive. It can be on a mechanical wheel, the kind of robot that we believe would be industrial robot, or the humanoids. Basically, so ROS initially requires some hardware which will be executing the final code. So on top of that, there will be a robot control. So all these robots will be having a hardware which is a robot controller. Now this robot controller will be having interfaced with the sensors, actuators. That's how we normally do. So yesterday we were discussing a lot about the electronics part. So you have the one main brain into the computer, that the robot, that is the controller. We were talking about the Arduino and the Raspberry Pi. Certainly you can't run it on the Arduino because it requires an operating system. So any robot hardware which is having an operating system, you can run the ROS on top of that. So we need to have drivers of the various sensors and actuators. That's a very important part, because ROS will be communicating on the application layer. So at the bottom layer, you should have some kind of drivers available for these sensors. So whenever we build ROS applications, we always, or select the ROS, the hardware for implementing ROS, we will be ensuring that the drivers are available. Unless otherwise, you have to write your own drivers. That is also feasible. So whether it's a stereo camera, whether it's a LiDAR, IMU, GPS, most of the libraries are already available in the ROS. So you don't have to worry. So most of the hardware manufacturers are supporting this initiative. So they are providing their own library. So for these sensors, it is available. Then for motion, Dynamic Cell has a very good libraries available for motion control. So you can directly use the Dynamic Cell motors, or otherwise you can write your own drivers for the some of the robot motor drivers. You need to have the ROS drivers to be written. Otherwise, people have already done, so that you can directly use it. Then, as I was saying, then you will be running this ROS on the PC or an embedded hardware. So that makes the ROS executing and communicating on different hardware platforms. So ROS is running on the OS. And then on bottom of that ROS, you will be having a drivers for interfacing with various sensors and actuators. And then you will be running algorithm in the application, then they will be able to sense and control the robot. That's how the basic idea of functioning of the robot using ROS. Let me just give a quick idea how it will be working. So that's how the basic learning exercise start, that you have to create the workspace, and where we will be saving all our programs, the source code, and then we'll build it and then run it. So that's how this Catkin is in a workspace that you will be creating. It's in a ROS build system, so that you will be. So certainly those who are not much familiar with the Linux, they may find initial trouble in understanding this terminology, but that is how all Linux compilers and the programs supposed to work. So we have to use CMake, and then we have to just build it and then able to generate the binaries to run them. So we'll create a workspace over here. We create a source folder here, and then initiate the workspace. So the necessary make file will be generated, and then finally you will make it, so that you will produce in a binary files in the build folder. I'm not going into these instructions, just giving you an idea is how it's supposed to work. So that's how there's an installation location in the Linux when you install it. So Ubuntu, it's going to sit into the OPT ROS folder, and then you will be able to create a workspace. You have to source it, because then it has to refer to the installed location. Many times you can have multiple versions of the ROS also, so that any version you would like to use, you have to source it first, and then it is available for access there. Not going into detail, just give you some idea on the functionality, how the ROS is supposed to work. So there's a ROS master that you have to run, which we call as a ROS core. So whenever we supposed to start the ROS, in the ROS one, again, I'm just saying in the ROS one, it's a ROS core. ROS 2 may not be using this ROS core concept, but those who are working in the ROS one, they can understand this. We have to run the ROS core. That is a core program, or the ROS master that will be running. It will be having its own IP address, because identification of the core is very important, because other nodes will be connecting from different hardware as well. So they all will be identifying this one as a ROS master. So ROS master should be known to all the hardware platforms which will be communicating with the masters, and the different applications will be initially registering to the ROS master. And from there, then once you register your application, then they can communicate directly. So you will be, this whole architecture is based on the subscriber and publisher model actually. So you should understand that. So there are publishers which will be publishing some certain messages or the informations, and those who are interested, they will be the subscriber for those messages. For example, if we have a group of 20 people, some of them may be sharing some information, but they may not be telling specifically to someone. They will be just broadcasting it. Yeah, I have this information. And then those who are interested, they will subscribe to that information. So same way the application programs are publishing some information at a certain frequency, they will be continuously publishing that information. Then there are other programs which are listening to this information, which once those who subscribe to this information, they can get that information. For example, one temperature sensor will be broadcasting the temperature information, but if it is in a thermostat application, it can subscribe and get that temperature value. If other application is not interested, then it may not be subscribing to that. So that way the concept of the publisher and subscriber is being used in implementing the ROS. So in this figure, if you can see that there's a talker is a program which will be talking, means it will be publishing some hello world kind of for example, to understand, let's say just publishing hello world. And there's a listener application which will subscribe to this information, and it will be receiving that information. So that way multiple programs, multiple nodes are communicating among themselves. So that's how the distributed processing happens. So you can write one program just to take care of the sensor data and just understand that what is around as an obstacle, and then it will be publishing the obstacle information. That's all. There may be other program which will take this input as an obstacle information and maybe then deciding the navigation algorithm and implementing navigation algorithm to decide how to overcome these obstacles. So that way the distributed processing is a very important strength of the ROS. So in this case, you will be having multiple nodes. They are communicating among themselves. Now, there are various means of communication. That's the important part. So once you have multiple programs running, how you will be making them communicating, that they will be sharing some messages on a topic. So that's how we define that. You have to identify which topic is relevant for the communication, and then they will be publishing the messages on that topic at a particular frequency. That's how they are communicating. So various nodes are communicating in this fashion. So like this, if you see here, so there's a topic we can understand, you have to identify, and then the node will be publishing. So this is a publisher node. It will be publishing some message on this topic. And there's a node 2 is a subscriber, which will subscribe to this topic, and it will be receiving all the messages being published by the node 1. So initially, when the application start, it will be first registering to the ROS master. Any application which will be now starting will be first communicating with the ROS master, registering it, and then it will be start communicating with the other. So while registration, it will be able to fetch the information which node is publishing which message, and then it will be subscribing to that message. Now that's how the ROS master is supposed to run first. Without ROS core, your nodes will not be communicating among themselves. The important part is that the messages are not routing through the master. They are only used for registering with the master. After that, the message communication happens directly, because once they are able to identify what is the location of the node 2, what are the node name, and what are the topics that it is going to listen, so then they will be communicating among themselves directly. There are certain commands which will be helping you to just understand what is happening over here. So that is how you will be able to run this. So what I will do, just give you a quick look at this. So I will just go to my another system where I'm running this ROS to just explain you. So what I just want to show you here, so this is a system I'm running ROS here. So as I was mentioning, first you have to run the ROS code. So that is how you can start the ROS operation here. So I just made the ROS core running, and this has to keep running actually. You should not stop it. So ROS core, it will also mention which distribution it is running. So it is saying ROS distribution is the Noetic that I am running. And then I think the IP and the information about the ROS master is also available over here. So this you can define as an IP address. Normally the name is not being recognized by other systems in the network, but what we will do, we'll make this setting available into the .-rc file itself. So you can declare that what is the ROS master IP address. That's how it will work when we are connecting with the multiple systems. Now I can go to the another so we can check which nodes are running here. So you can see there is only one default node is running, that is a ROS out. That's all. So whenever we run any application, then you will be able to find out which is the meaningful node. This is just a default node to publish something on the screen itself. That's all. But I can just make that what I was just mentioning, the talker node running. Let me just go back. Yeah, so there is a tutorial already available. If you just look at that program, I will show you in the slide also. That's a talker. So for example, if I just want to run this talker, if you see here, it is publishing an hello world information here. So that's how it is continuously publishing. This application that talker is running as a node now, and now if I just go here and check it actually what is running. So again, I will go to ROS node list. Now it says that there's a talker application running, and they also add a unique identifier, because each node should be uniquely identified into the network. So this talker node is running. Now nothing is happening on this actually, but node is just publishing. We are not doing any other action. So this is one program which is continuously publishing this information. Now I can go and I can just run another. So it will be keep on publishing information at a particular interval that you can just write in the program itself. Now what I can do, there is a listener node over here. So what I can run now, another application which will be listening this, what it is being published over here. Now this listener node is now running. And if you see here, I'm not publishing. I just stopped this talker node over here. Now, if I run this talker node, you'll see that it start publishing and the listener node start receiving this message. So this node is saying that I heard this hello world at this point of time. So this is what the listener node is working. This is what the talker node is working. I can just now have a quick look at the nodes running. So you can just check which all nodes are running. So there's a listener node, there's a talker node now running here. You can also see on what topics this informations are being published. So you can just go to ROS topic and list. So now if you see here, the messages are being published on a topic that's a chatter. So that's how the simple text information is being published on this particular topic. What message is coming, you can just go to the ROS topic echo. Sorry. So you can just check. See, these are some of the debugging methods that you can just find out. So I can anytime check what is being published on a particular topic. So that is how this is just a simple example where the information is being published in the text format only. So then independently, I will be just fetching out what is being published on this topic. And I can also check what type of topic it is. Topic info. So it can give you some information about this particular topic, that this is a standard message of the string type. So you can see there are various type of messages in the ROS. So we need to understand, and the meaningful messages are, for example, you are publishing some velocity. So then it's a meaningful message that now you need to understand what is being published. So most of the time we will be publishing the 3 linear velocity components and the 3 angular velocity components. So those messages are coming into the geometric message. That's a twist message. We call it a twist message. So whenever we are intend to run a robot, we will be having those messages being published. So what I will just do, just stop this node running here and just stop this node as well. And let me just show you that simple robot application that will be running. And Color will then give you the demonstration on that. So for example, I'm just going to launch a Turtlebot. Turtlebot is a very common robotics platform to run the ROS. So I will be just launching this. Yeah, model I have to just set. Yeah, just a minute. So this is a gazebo simulation environment which is being used to simulate the functioning of the robots. So if you see here, this is in a world that is being created over here. So I can just show you this. You can just have a look at this. So this is just an environment with the pillars, and you can just see the robot here itself. So this is the Turtlebot. And now because you spawn the robot in the world, this is the world in which you can test this robot functionality. Now I can go and check what all nodes are available to me. So I can just go here, ROS node list. And because you have a Turtlebot available, so there's a gazebo also, and I will just check the topics. These are the topics now, because I have placed the robot over there. So there are various topics on which the information is available about the robot and then sensors. And I would also like to control the robot through this. So if you can look at this, there's an important message over here, the topic over here, that is in a command velocity. CMD well, this is an important through which I will be able to control the robot. So anything published on this topic, you will be able to control the robot. So in that case, let's see that what type of message it is. So again, I will just go ROS topic info and CMD. So well. So you'll get that this, as I was telling, this is a twist message. This is a geometry twist message. I can also check what is being published on this ROS topic echo. Yeah, so what I will do now, let me just yeah. So if you can see here now, there is another node I made to run over here. So this is another node, which is a tally operation node here. So you can see that I will be launching this as another node, which will be publishing now the CMD values. So now you can see there's a one node which is running this gazebo environment with a robot inside it, and there's another. Yeah. This is another node I will be using to control the operation of this robot through the teleop mode. So I will be using keys to control the robot. And then I will be also listening what are the values that are being published over here. So if you can see this, these are the values of the CMD well. It means there are three linear velocities, X, Y, Z, and there are three angular velocities about X, Y, and Z. So if you see here, if I just give a command through the teleop. So teleop is saying you can move around by these keys actually here. So if I just make W, you can see that I'm publishing some velocity now, and your robot will start moving forward actually. Now you can see here. Because now I published on a linear velocity, so it start moving forward. And I can also see the change happening over here. So you can see here, this is a linear velocity now, what I have just given, so it is being published. If I would like to rotate on this, so I can just go to the teleop again, and you can see if I just give a command to angular velocity, your robot start turning. So it means that through one message that is publishing on the CMD well, I will be able to control the motion of the robot. Idea is that how the various environments are working in this case. So that is what I was just trying to explain you. So distributed processing, that is very important part over. So I am running multiple nodes here. One node is running the gazebo. Another node is basically the tally operation node. So these two nodes are communicating on the topic that is CMD well. So whatever tally operation is publishing is being captured here, and then this robot will be listening those messages coming on the CMD well, and then it will be moving, or it will be controlling its own hardware to make that motion possible. So that is the way this these robot simulation can be easily done in this gazebo environment. Another important aspect of the ROS is that whatever you will try out in the simulation, you can, as it is implemented into the hardware. So this simulation environment is giving you a very good platform so that you can try out various algorithms. And then you can use the same program, whatever you have used. So different nodes, whatever you have written to make this robot moving, can be physically implemented onto this turtle bot. So whenever we do simulations, immediately we can also show the connected robot, and we can just run the node onto the turtle bot, and it will also be able to make it moving like this. I'm just moving it dummy. There's sorry, the constant motion I have given without having any sensor in place. So but there's a possibility this robot is also having a sensor which is now scanning that. So there's a lidar on top of this robot, so you will be able to see the messages coming from the lidar also. Let me just reach out to that. So in this case, this scan message that you can see over here, this scan message, So there's an odometry being published by the robot. There's a scan being published by the robot. So it's a lidar data, lidar scan. So if you see here, I just want to see last topic. So it's a laser scan data. So that way, the topics and the message types are standardized like any data structure in any of the programming environment. So this is being standardized here. So laser scan is now again a type of message, and we need to understand what are the field in the laser scan. So that information can be taken from the documents that are available on the website. Now what I can do, I can just show you what is coming on this message. So this run this. So this is the data that you can see also. Means what is now coming. So because lidar is continuously rotating, so all 360-degree, what is the value that it will be experiencing as it is moving? You can easily visualize that. You can easily see that actually. I'm just seeing right now in the form of the raw data. Now there are means available through which you can visualize this data also. So there are various visualization tools available, where RViz is one such visualization tool through which you can see that this laser scan, what you are seeing as a number, can be also seen as a distance from the obstacle. You can just see that graphically, whatever is shown in this terminal as a text format. So that way, these are the various tools available to understand the simulation. So your robot is still moving because you have not stopped that publishing of the message over here. So once you have given a velocity, unless you give a velocity to stop, it will not stop. So I have given a velocity 0. Now it is stop over here. So I think though it is very short, I just want to give you a quick glimpse of what is being done, what initial understanding you can have about the ROS. Certainly there's a long tutorial and long sessions required. That's what I was just saying. It's such a vast field to learn and understand. This is just a quick initiation on that part. So rest of the time, what I will request Kalahar to give you the little bit more insight onto the same demonstration which I was showing you. So over to you, Kalahar.
Thank you so much, sir. It was a very nice of you to explain everything in detail. So I will start from the visualization part. Yes. Just confirm once my screen is visible.
Yes, we can see that.
Yes.
So first of all, we have to start the gazebo. As the sir said, gazebo is a virtual environment in which we can simulate the robot, because sometimes we need to test everything before running into the physical hardware. Otherwise,
Color.
yes, sir.
Sorry to interrupt. Can you just show how from which source how to install Gazebo also? It will be better.
Sir, I have to complete this.
No, I think Venkat, it will take time. Gazebo, if they go to the ROS wiki and they search it, it is easily available instructions over there.
Okay, so then it's fine. That is fine. That is fine.
And if you install the ROS, Gazebo can also be installed as a part of this if you do the full installation. So you need not to worry to install it separately also.
Okay, sir. Okay, sir.
So this is a gazebo environment. You may see it's a little bit different than what sir said. So there are multiple worlds available. It's like a multiple simulation, multiple scenarios in which you can test your robots. So let me just give you a little bit more examples of that. So if I say, so there are like stage 1, stage 2, stage 3, stage 4, world, one is house also, auto race is also there. So you can try multiple environments here. Let me go with stage 4. Okay. So here, as the sir said, we can control the robot using tally of operation. So I'm not going to repeat what sir said, but just for example, I can control my robot by using tally of twist command. So as you can see, I'm able to move my robot around. So quickly moving ahead, there is a scan topic which sir discussed about it in the last. So if I say ROS topic, list. So here you can find the scan topic. Just a moment. Yes. So here you can find the scan topic. So if I just say ROS topic echo scan. So here you will be able to see entire LiDAR data in a raw format. So if you say it more closely, you can say that let me just move a little bit ahead. Yes, the minimum angle is 0.0 radian and the maximum angle is 6.28 radian, which is 2 pi. So it represents that our LiDAR is 360-degree LiDAR and increment between each reading is 0.017. So if we divide 0.017 by 6.28, we can get the number of points we are getting along the frame. So let me just go to visualization part of the same. So RV's tool is a very feature rich tool which allows us to implement many features, visualize many features of the robots. Let me just start a quick example of that. So here you will be able to see the robot in between. Let me just enhance the size of the LiDAR reading so that you can see it more clearly.
Color, you can zoom also. Yeah, it's
Yes.
good. Fine. It's nice.
So as you can see, according to the robot's perspective, the LiDAR's readings are represented over here. Here, our fixed frame is Odom. It means that all of the data is represented around the Odom frame. Odom frame is the position of the robot. Let me just rearrange the windows a little bit. Yes. So, is it visible clearly?
Yes.
Okay. So here you can see that robot is seeing all the visible world around its LiDAR in 360-degree, and it's the same data what we saw in the terminal as a text format. This is just visualizing it so that our brain can process it very easily.
Yeah, color, you can move it through teleoperation so that they can see the
yes,
change in the laser scan also. Yeah.
Yes, it's right here. So if I start moving my robot around, you can see the changes in the LiDAR readings. As the robot is moving along, you can see the LiDAR readings are changing accordingly. So, yes.
So whatever is coming in the text format, these are the message that you can subscribe and you can process that information. So you can easily find it out what is the closest distance from the obstacle around it. And then you can just command the robot using command velocity so that you can make it moving to the different location.
Yes. As you can see, there is a topic here, scan. So it's the same topic which we saw in the terminal. So here we are just providing it to the laser scan to visualize it. So, sir, shall I move ahead?
Yes.
So after this comes the part of the SLAM, which is used to map entire area. So let me just close the RVs part. Okay. So using the SLAM, what robot does, robot marks the entire area in terms of occupied, free or unknown. So here you can see that what robot is saying is this all area is, let me just zoom in a little bit. All of this area is free. These walls are occupied. You cannot go through that. and these are the unknown areas. So if I move robot a little bit in the arena, it will know more about the its workspace. So let me just move it little bit. So here you can see that robot is already generating a map of its surroundings. It's a very accurate map in terms of, because the simulation is a very ideal world. So here you can see that map generation is too perfect. So once we finish the basic mapping, we can move ahead to start the navigation part.
Anybody having any question on whatever we are just demonstrating and discussing, though it is too early to at least get a full understanding, but at least if you have any query or guidance, that you let us know.
So as you can see, our map is pretty complete now. So I'm going to save this map into the PNG file and the YAML file with its parameters. So let me just run the command for it. Here I will be saving my map into particular location. Once it's done, you can see the map in a PNG format also. So here you can see our map in PNG format. It's very clear, and you can edit this file also if required. You can mark some areas externally that robot can avoid that areas. So once this process is done, one YAML file is also there. It is there to represent some parameters regarding the map. For example, resolution, origin, occupied threshold, free threshold. As I said, threshold, for example, the value is from 0 to 1. So if the value is less than 0.1, sir, is it visible clearly?
Yes, though it is
Yes.
small font, but it is visible here.
Yes. So if the value is less than 0.196, it will be it will be considered as a free space. If the value is greater than 0.65, it will be considered as a occupied space. But if value is ranging between these two, it will be considered as unknown space. So if we say in the map, there is a dark black area, there is a white area. Let me just, yes. So black area is the occupied space, white area is the free space. But this gray area is the unknown space. So if there is too much of the unknown space, robot can figure out about it in real time also. If the robot is moving from it, and if it's going to the area which is not mapped perfectly, the local planner works in real time ladder readings, will figure out its way out from that. So let us just quickly move to the navigation part. So now we do not need the tally of operation, because now robot is going to move automatically. So let me just quickly turn off the slam because our mapping is done. Now we will start the navigation process by the same map we stored here. My bad. As you can see, let me just rearrange our windows. This is the RVS has loaded our map in the background. Over it, it is showing the local cost map of the robot. Local cost map is the let's say it is approximately 1.5 meter, let 2.5 meter approximately in the length and width. So what robot does, that robot makes such intuition about its surrounding and creates a local cost map based on it using the LiDAR readings. What you can see in the background is the global cost map. It is made through our map, but the local cost map is generating through the LiDAR's reading. So as you can see, our robot's position is not accurate because initially navigation stack doesn't know that where the robot is in the map. So we can just guide it that you can imagine the robot over here. So as you can see, our LiDAR readings are not perfectly matching, but it's little bit off than the real readings. But we can depend on the robot for a little bit correction of that. It is called the localization. So you can see all the green arrows here. These are all the possible positions which our robot is considering that it is in the map on this position. So if we move the robot around, this scope will be narrowed down. So let us see. So as you can see, the position is getting too much accurate. So within just few seconds, it will be almost at a single point. As you can see at this point, the robot is pretty sure that it's on this point in actual world also. And as you can see, it is perfectly there. So now we are able to move the robot around using point-to-point navigation. We can say that go at this place. So robot will automatically find the global planner will find the approximate path to that position, and the local planner, which follows the local cost map. You can see this yellow arrow right here. It will try its best to follow the global plan, but it will try to avoid what it's in a local cost map also. So if I place something in a real time, let's say I place this obstacle here. Okay. And now it doesn't know about it that it's here. And now I'm trying to say go at this place. Okay, it's not in. Okay, so never mind. So basically it follows the shortest path possible. And as you can see, it is already detecting the sphere we uh, kept here. So if I will try to say go here, then it will automatically avoid that sphere and go from alternate path. As you can see, the map doesn't know about this sphere. So it was in a moment it was trying to go from here, but as the local planner didn't allow that, it went from surrounding. We can play a little bit more also. If I want to go here, there is no practical path to reach this position. So robot will never impact the obstacle. That's the main primary goal, to collide with anything. So if it doesn't find the proper path, it won't move ahead. As you can see, it is going from recovery behavior. So what recovery behavior does, that it clears the surrounding cost map and creates it again by rotating around its own axis. But in this case, there is no path possible. So after some time, as you can see the real-time commentary here also. Yes. So here you can see that recovery behavior started. Rotate recovery cannot rotate in place because there is a potential collision. So clearing the both cost map to unlock the robot. So here robot is continuously trying to find a better path to reach its position, but it's not able to find one. So we can just shift the sphere also. Move. And now robot will be able to find the position path to its target. Okay. So in this case, we are providing the target points from the visualization software. In general case, it is not the case. You have to rewrite some code. For example, my requirement is this, that my robot should go from this point. Let me just maximize this window. My requirement is that these are 4 workstation, 1, 2, 3, and 4. And my requirement is that robot should go from workstation 1 to workstation 4, 2, 2 to 3, 3 to 4, and to 4 to 1 continuously. Let's say it's a pipeline process. So in that cases, I cannot hire a person to just keep pointing out robot to a particular points. I can write the code for that also. So if I see Ross topic list, there is one topic called move base goal. So if I just print out all the values it is getting on the topic, Ross topic echo move base. Okay, initially there is no value. Now let me just give it a particular point to move. So as I gave it a target, you can see I'm getting one message here. It is saying that goal, the target pose, and the pose. Pose is the position in the map. X, Y, Z are the coordinates, and orientation is in terms of 4 values X, Y, Z, and omega. So as you can see, if I say one more point, I can find that point here also, that it is x equals to 2 and y equals to minus 1.8 almost. So I can publish the messages to this topic directly also. So this is a little piece of code here in which I'm publishing certain points to that topic. There is one action called move base. What it does, it provides some features like let's say send goal, wait for the results. So what wait for the result does, it waits for the result to be appeared. For example, a mission successful or mission failed or a timeout. So if the 60 seconds is passed after giving the goal location, it will move to the next goal location considering that goal is not accessible. So in this code, I'm providing 4 points to the in sequential order in an infinite while loop. It's not an infinite while loop until the ROS is on. So if I just run this code, ROS run practice driver .py, it will command my robot automatically from point to point in a sequential order continuously. So as you can see, my robot will travel from point 1 to point 2 to point 3 to point 4. I can add some object in between also to make it little bit more dynamically. But object should not differ too much from the map. Otherwise, it may mess up the plannings because robot can only visualize what is visible in the LiDAR. Apart from that, it is dependent on the map we provided to find the perfect path. If it finds something new which is not in the map, it will make it hard for it to reach the goal. For example, in this case, robot won't be able to go from here, and the map isn't aware of that. So map will suggest to go from here only, but robot won't be able to go from this way. Okay, in this case, it found the alternate path also. Yes. Sunil sir, this is
I think,
the
yeah,
end of my.
it's a nice demonstration that you have given. So that's really nice. You have explained the navigation part as well. Otherwise, these are some of the things you have to learn and after spending some more time. But at least Color give you a quick overview and idea how the goal can be specified by the RWAys, how the current pose can be specified, and your robot is doing all the global path planning and the local path planning. So good. I think thanks, Color. I think this much is good enough for the today's session. And there are two questions from Dhananjay. Could you please show us the application of object detection using camera in ROS? Certainly we can, but because of the limitation on the time, we can't do that. There's a very good application where you can detect the object, but I look forward. I think Maitri can cover that part in our follow-up session. I think so.
Yes, Dr. Jha.
Yeah, that's nice. So I welcome Maitri from MathWorks to take the follow-up session after this. So she will be explaining more about the ROS and MATLAB interface, how it can be done.
Yeah.
Another question is that the short path depends upon the LiDAR quality or on the computer performance. No, shortest path is all on the algorithm actually. So it's not dependent on either actually. Neither the LiDAR is only the resolution of the LiDAR will be defining the I should say that the density of the points that it can sense in the obstacle field actually. So as it is moving, it will be keep on updating. But if any object is coming in between those resolved points, actually, then it will not be able to detect immediately. So that are the limitation on the LiDAR quality. But computer performance is only impacting the speed at which it can be performing. So for example, if it is not running very high, then the robot should not be moving at a higher speed because it cannot do the processing at that speed. So at the slow speed, I think you will be getting the same performance. So that is the limitation here. Shortest path is completely on the algorithm, which algorithm is being used to generate that global path and the local path planning algorithm. So it's not dependent on the hardware either, right? So these are the quick responses. So I now request Maitri to take up the follow-up session. Welcome, Maitri, for this boot camp, and then over to you now.
Thank you, Dr. Jha. Let me share my screen.
Kalhar, you can stop sharing. Yeah.
I'm not able to stop the screen sharing. I don't know.
Okay.
Let me just leave the meeting and join again.
No, let me see if I can do something. Yes, thanks.
Okay.
I think
Thank you so much, sir.
I stopped it.
Okay, thank you. So yeah, Maitri, now you can take it forward.
Just 1 second. Let me try to do that. Just let me know if my screen is
Yes,
up.
yes, we can see that. Yeah.
Okay. Awesome. Thank you, Dr. Jha, and everyone for having me here today to talk to all of you all who are the budding engineers of the future. I'm hoping that all of you all are having a good time learning over the last 2 days building your robots. So I am here to talk about how we can help you build your robots a little better using MATLAB and Simulink. My name is Maitri, like Dr. Jha said, and I work at the MathWorks, who are the makers of tools called MATLAB and Simulink. MATLAB and Simulink is a technical computation tool which is used by engineers and scientists. So let me just delve into the topic. I'll try and talk about deploying and interacting with hardware using Simulink, and we'll cover parts of ROS, since today you all are talking a lot about ROS and how you can use ROS for navigation, deployment, and basically distributed systems. So we'll try and talk about that. And in the meanwhile, let's say when we are when I'm presenting, if you all have any questions, just feel free to put it in the chat or in Q&A. We'll try and answer those. So with that, let's get started. This is just an overview of MATLAB and Simulink and the MathWorks tools. There are more than 5.6 million students all over the world who have unlimited access to the tools through their campus-wide licenses, and they are being used for hands-on learning, for gaining job opportunities, and to help with research productivity. So you can read some of the quotes which have been written here. I hope you all can see my screen okay. Right. Um, and these tools are used to design, simulate, and test many of the products that we rely on every day, which could be an aeroplane, a car, a rocket. There were, washing machines, the smartphones that we're using, and definitely the autonomous robots, right? So this is all great. But what interests all of us who are here is how can these tools help us for our competitions, right? Now, these are some of the videos which you see on the screen. These are different student teams in participating in competitions, just like Robocon. These teams have used the tools to develop their car, their vehicle, which is on the surface of water, and the soccer playing robots. So these are students like y'all who have used the tools for their competitions. So the first question that you all might have is, what all can we do with the MathWorks tools, right? So these are some of the examples. These are just a few of them. So you can use it to plan your path. You can design a path flow following system with obstacle avoidance. You can work on image processing. You can work on physical systems. There are lots of things which you can try, but we'll focus on just one topic today. But before that, I just wanted to show how National DD Robocon teams have used the MathWorks tools in the past. So these are just some of the examples of how the teams have used MATLAB, Simulink, Simscape. These are just names, but essentially how they have used the MathWorks tools for making their workflows easy, or making their robots in a more effective way. So this is 2019. This is Team Automatons, which use MATLAB and Simulink for building their quadrupod. This is in 2020. This is just an example where Team KJC used the tools for designing their throwing mechanism. And this is Team DJS, which used the tools for designing and understanding which mechanism works better for them, for their arrow throwing robot, and for their defending system. So these are all some examples of how you all can possibly use the tools for designing your systems better. And all the three teams have written blogs along with us to share their journey of their learnings. How did they go about it? What were the obstacle points that they had? How did they overcome them? And how did the tools actually help them to design or select the right mechanism or work through it? So this is whatever you'll see here is more on terms of selecting or let's say designing their physical system, their physical model, which is the mechanism that works better. Will I get that range where my rugby ball has to reach, or my arrow throwing mechanism has to reach in a pot? But what we will focus today on, like Dr. Jha said, is we'll try and cover how we can interact with hardware and deploy code on a hardware using Simulink. So we'll try and cover the question, which is obstacle detection using camera in ROS. So this is the example we will go through. Here we have a Raspberry Pi. We have a servo. There's a camera, and you see it's detecting a green colored object. So we'll try and do an object tracking example like you see here. So this is the agenda. We'll talk about deployment to hardware. Then we'll talk a little on Simulink plus ROS. Then we'll talk about how you can deploy ROS nodes on a hardware, and in our case, we'll try and talk about how we can deploy it on a Raspberry Pi. It need not be just Pi. It could be any ROS enabled hardware which is supported, and we'll look at object tracking example, and then we'll just go over some of the resources that you all can use, and you can ask questions in the as the session goes on, but we'll have some time for Q&A, right? So with that, just wanted to introduce MATLAB for everyone who's seeing it for the first time. MATLAB is a numeric computational tool that can be used for data analytics and visualization. It can also be used for algorithm development in various domains, like image processing, statistics and machine learning, robotics, deep learning, and so on and so forth. And Simulink is a platform that is used for model-based design. Here we drag and drop blocks to the model, and which could be designing an aerial vehicle, it could be a robot, it could be a car, right? And Simulink typically is used for dynamic systems, systems that change with respect to time. There are, let's say, some inputs or some parameters which are changing in our system that lead to changes in the responses. So that's where Simulink is used essentially to work on dynamic systems. And it is used in simulation of physical systems. And once you have the system set and tested, you have worked through the simulations, you can just click a button, it will generate code which will go directly on the hardware, right? And again, Simulink is used in different domains such as control systems, signal processing, communications, and so on. So let's say we have a system where you have designed a logic, right? Let's say you have an image processing system, a control system with some high-level control or some PID controllers that you have designed. Where do you want this control to eventually run, right? You want it to eventually go on a hardware, which can be, let's say, a Raspberry Pi. It can be a Lego EV3. It can be an Arduino. It can be an FPGA. It could be a GPU. Correct? It depends on what is the hardware that I have available at a given point of time, or what is the hardware that I have selected. Right? Using MATLAB and Simulink, you can easily connect with this hardware to have your code on the system. But what do I mean by interacting with hardware? What I mean is you can deploy whichever logic that you have designed. For let's say example, you have a vision and control. You can deploy this logic on the hardware. So you can design this logic, let's say, using block diagrams. And you can just click a button. It will generate the code. It will go on the hardware, and it will let you interact with the hardware. You can see the live values of sensors. You can change certain values and see how the hardware reacts. And you can do this using something called as hardware add-ons. And these add-ons are called hardware support packages. And we'll look at these hardware support packages today from the Simulink perspective, because we are majorly working on a robot, which is again a dynamic system, right? Something that's changing with respect to time. So let me show you all how where you can find these. Let me just open MATLAB. So for again, someone who's seeing MATLAB for the very first time, this is how it looks. This is the MATLAB tool strip where you can find a lot of things. There's there is new script, and you can open files, you can find files, you can import data, and so on. This is the MATLAB command window where you can type commands. Let's say I'll say, let's say we'll say hello, and we'll say, let's say B is say robot, right? And we can say C is equal to A plus B, and oops, sorry, it's not an addition, right? So we'll say C is equal to concatenate both of them, and we'll get hello robot, and you can see all the results on here, which is called as the workspace, right? And all the variables which we, our current directory can be found over here. Now, I was talking about add-ons, right? The hardware add-ons. So what you'll have to do is you can go to home and you'll see a button called add-ons here. So you can just click this button and you'll see something called as get hardware support packages. You can just click on that and it'll open up a page. And you'll see number of hardware which are listed here, including Xilinx, there's Intel SoC devices, and there are our favorite, Arduino and our Raspberry Pi, and the, for that matter, even Android, right? So there are multiple hardwares which are supported, which you can check, and these are the ones where you can just click a button and the code gets generated and it directly runs onto the hardware. That, let me just open the slides again. So this gets me to the question. Before that, again, I'll just summarize what I mean when you install an add-on. Is you can connect to a hardware to your system. You can follow certain steps or procedures and just click a button. It would generate C code and it will deploy on your hardware, right? Now, this is a question for all of you all. Can you all, what are the different hardwares that you typically work on for National TD Robocon? You can just put it in the chat. Yeah. Something like an Arduino, Arduino Mega, Arduino Uno. Probably you all are using Raspberry Pi. Any of you all are using Camera, Raspberry Pi, Arduino, ESP, Jetson. That's nice. Okay, Jetson Nano. That's great. So we have a lot of you all using GPUs, right? That's nice. So there are different hardwares we use. So this is good. Let's go to the next slide. Great. This is, again, just an example of deploying code on a hardware which is Lego EV3 Mindstorm at the moment, and we are visualizing it as it moves. You can see where it is moved, how it's going on around the space, and you can also notice the movement in the visualization on the left side. If it moves to a different space, let's say by mistake, you not realize there's error which we have made. Let's say you can visualize and debug it easily. And the tool on the left helps you design a high-level control for your robot using state machines. But we will not go in depth about it. And if any of you are interested, you can just write to us. I'll show our contact details around the end. Right. So now let's see an example. Okay. So this is a Simulink model. What are we trying to do here? There's a motion energy that we're comparing to a constant, which is a threshold. If the energy crosses over a certain threshold, our output is going to be high. If not, it stays a low. Now we can call it something to be, this motion energy to be something like a sensor. We are just simulating it, and we're constantly checking its value. When the value is higher than the threshold, right? The scope here is going to show us a value high. Let's think of this in terms of hardware. Let's say we want this logic to be on an Arduino board or a Raspberry Pi board. Let's just take Arduino board. How would we do this? Okay, we will have an LED which is connected to the specific pin that's connected to a register, and that will go to the ground, right? And the LED will glow when the output is high. Correct? So that's good. Now, how would we go about having this logic on an Arduino from Simulink? So all you can do is just change one block and instead of the scope block, you add the Arduino pin 9, and that's about it. You'll just have to select the hardware, just click a button, and this code directly would go onto the hardware. Now let's say we used Arduino last year, and this year I would want to work on image processing. So I've changed my hardware from Arduino, let's say, to Raspberry Pi. How would I go about implementing the same logic on the Raspberry Pi, let's say using Simulink? All we have to do is just change one block, and you just select the hardware, and that's it. All right, your model is ready to go on the Raspberry Pi. I'll just show the same model here. I do not have a hardware with me right now, so I'm just showing you a few videos of when I had done this on the hardware. So this is exactly the same model which I showed in the last slide. There's this motion energy, there's a threshold, there's a comparison, and I'm connecting it to Arduino pin 9. Now you'll see some additional things here. There's a knob which is connected to the threshold, and there's a lamp which is actually connected to this output here, and we're just displaying the motion energy on this visualization, right? Now I have deployed it on the Arduino. Okay, and actually I don't want to use Arduino this time. I want to use Raspberry Pi. How do I change it? So you just remove the Arduino. You just select the Raspberry Pi GPIO, right? You go here, you select the hardware to Raspberry Pi from Arduino, and just click on monitor and tune. And when you say monitor and tune, what you can do is you can visualize the results or visualize the sensor values or whatever output that you are logging. So when you do that, you'll see, so you see the Raspberry Pi here, you see the LED and the resistor, and I'm changing certain values here. But you'll see as this blinks, you will be able to see the result in Simulink as well. So this is where you can also see the results live on the Simulink model as they change. So that's about changing hardware. But oftentimes we need to tune parameters on the model, right? On the hardware, changing certain values, figuring out how they work. And this is where these interactive components help a lot. So this is an example where I'm changing the threshold, I'm increasing the threshold, and the results of when the LED is on changes accordingly. So you can control, tune and change the values on the hardware as the model is running out there, right? This is about working with hardware. Any questions? You can please feel free to put it in the chat. So with that, I just have a question. We saw how you can interactively tune, right? Are there any applications that you all can think of where you can, this can help you for your task at National DD Robocon? Let's say there's something on the hardware. You can visualize it and tune the values from your system. Any applications you all can think of where this is going to help you all? You can put it in the chat. Any thoughts? Let's say something like that. We have a nice answer on image processing. That's great. While you're using image processing, correct? When you're doing PID tuning, any other ideas that you all might have? These are very good applications, and we'll see how these can be done. There are some videos around these as well. That's nice. Okay, we have some videos around these as well. I'll share all these resources towards the end so that you can have a look at them. So with that, let's get into ROS, because we have been talking about ROS today, right? So like you all know, ROS has been used pretty much in development of large autonomous systems. ROS stands for Robot Operating System, but again, it's not really an operating system. It's a middleware for autonomous distributed systems. And at the core, ROS has a very well-established set of tools for messaging and distributed computing. And autonomous distributed systems can be very efficiently developed utilizing ROS. So we'll talk about this in the rest of the session. So here on the right hand side, this is how a traditional ROS enabled system might look like, which runs on a Linux system. There's a host of ROS enabled simulators and hardware, and through ROS network they can communicate with nodes that would enable you to have autonomy, to visualize, and so on. And on the left hand side, we have MATLAB and Simulink that offers tools for autonomous system development. Now, you might have components of image processing or path planning or controls. This is where MATLAB and Simulink would come into picture. And you may have, let's say, designed a high level or a low level control. There might be some image processing task which you might have done, right? And there is now a tight bridge to ROS from MATLAB and from Simulink. So basically, there are three workflows. The first is data analysis and playback. You can log the data from your simulation or from your hardware, and then you would want to bring it into MATLAB and Simulink environment for trying some offline tasks, for tuning, for understanding how your system would behave, right? The second is desktop simulation. This would be a live connection between ROS and an instance of MATLAB for algorithm development. And finally, there's deployment. The same implementation which you have developed or you have designed your PID controller. You want to you have prototyped something, and you can directly generate code which can act as a standalone ROS node on let's say a simulator or on a real hardware. And in this case, you would not need once you have deployed this, you would not need MATLAB to run after that. So that's the third approach. And what we will focus on is the third approach to deploy a ROS node. We will generate the C++ code node and deploy it on the hardware, which would be Raspberry Pi. And we will also use a little bit of approach to visualize the data that's published from a generated ROS node. So this is, like I showed at the start of the video, this is what we'll do. We have a Raspberry Pi. Let me pause. We have a Raspberry Pi, which is connected to a servo. There's a camera mount, and we have the camera. So I've used a USB camera here, just for the convenience of mounting it. But it could be the Raspberry Pi camera as well. I'll show how you can select the camera as we progress through, and then I've used some connecting wires to connect it to a specific pin of the Raspberry Pi. So what we'll do is we'll have the servo. We just have one servo, so we'll have it pan and track the green colored object. So So basically, what we have done is we have had a Simulink model which has certain image processing and certain controls. We have generated a ROS node, and it's deployed on this Raspberry Pi, which is running on the hardware to track the green colored object. And what you see at the background is another model which is used for visualizing to make sure that we're actually tracking to see the camera image and to see the servo angle, right? So basically, there will be. I am sure you all are comfortable with the ROS publish and ROS subscribe, right? If you all are not, I can just go over it really quick. But just put it in the chat if you all are not comfortable with me mentioning about publishing and subscribing. So basically, what's happening on the Raspberry Pi? It's publishing 2 topics, which is called /camera. Okay, that's great. So we are publishing something called a /camera and /servo angle. And in Simulink, what we're doing later on is subscribing to these 2 topics to visualize them. So that, with that said, this is the requirement. I had used a Raspberry Pi 3B Plus. Again, a USB camera, a servo mount, a few, a little bit of sellotape, and some connecting wires. And what I've installed is from the hardware add-ons, I've installed the Simulink support package for Raspberry Pi. So in this example, we will deploy a ROS node that has a vision and a control algorithm on the Raspberry Pi. The Raspberry Pi's control algorithm, which we have deployed, right, it will take action. And what it will do is it will send the angle of, this is the Pi, and it will send the camera image along with a centroid, which is detected, along with what is the servo angle. It'll publish it, right? And what we will do is we'll have another model, which is on our desktop to visualize. So this is MATLAB and Simulink. We will subscribe to this topic, and along with that, we will also have some commands to start and stop, right? So with that, let me just open the model. Here we are. Let's just clear the workspace, and we'll close the other things. So here, so these examples are available. I'll share the link on how you can access these after the session. So here we have, like I said, we have 2 models. We have one that is for Raspberry Pi, and we have one that's for our desktop or our system. So what we'll do is we'll just open the Raspberry Pi model. Right. So again, like I said, if you all have not not familiar with Simulink, let me just quickly go through it. So this is the Simulink. This is the canvas where you'll drag and drop blocks. All these blocks which I have used here are available in the library browser. So you'll see some things here. There are different things in terms of what are the blocks that are available. What I have done is added a video capture block. This is a block which is specific for Raspberry Pi. So if you'll get this if you install the Simulink support package for Raspberry Pi. So let me show this. So this is a Simulink support package for Raspberry Pi, and these are, you'll see Raspberry Pi written at the top. So these are hardware. These are blocks specific to that hardware. So I've used a camera. I have R, G, and B. These are the 3 different channels. I've just packed those channels together to give me one signal. And there's some image processing and control algorithm which is happening, which is the logic, which the algorithm that's developed. So I'll quickly go into the algorithm. So here we have done some blob detection. That's to detect the green color. And what we're doing is we are sending the output of this is the centroid basically. So there's some logic written here. And what I've specified is a threshold. So this is basically RGB threshold values, which signify a minimum and a maximum range. So basically, if R, G, and B colors are between 75 and 115, 126 to 102, 80, 186, I'm saying it's green color. It could be different. So I'm just specifying that. And I'm just finding the centroid, and I'm sending the X and Y as the output. So this is basically the X and the Y of the centroid of the green color object which is detected. And then what I'm doing here is I'm just drawing circle on the centroid. And after that, there's there's a control logic that's going in. I'm using the Y value just because we are going to pan only in one direction. That's the Y direction of the camera. We'll get the object position, and basically this is the same interface which I'd shown at the start. This is just modeling using state machines. So I have 3 states, which is tracking. When it's, when the green color is in frame, it's going to start, following that green color. If it's not, it'll wait for a while, and then it'll start seeking. So if I remove the green color object from its view, it'll start tracking. It'll keep seeking for finding a green colored object, right? So this is just the control logic that's in here. And at the output, what do we get? We get the output image, which is going to be a camera image with the centroid. And what we're doing here is we're just using the sensor messages image. So you probably have seen a multiple number of images or message formats that we have, right? So I have just selected the image format, and what I'm doing is I'm just replacing the content in it. So this I'm just specifying what is what is the format that I have, what is the dimension that I have. Similarly, what we are doing for servo is we are using a standard uint8, and I'm just replacing the data with the servo angle, right? And at the same time, we are also giving a signal to GPIO pin 18. That's where the servo is connected, to ask it to take the steps to track or to seek, right? So this is our Raspberry Pi model. So, but to get started, what you'll have to do is you'll have to just type ROS in it. That'll launch the ROS core, and it'll start a ROS master it'll start a global node on your system. And then what you could do is, I don't have a Pi connected, but let me just show how you would go about it. I have selected Raspberry Pi here. I would typically test the connection, but because it's saying that my Raspberry Pi is supposed to be at 173, but because I do not have it, it'll say I'm unable to connect it at the moment. But if you want to manage your device, you can just click on, sure, it's come up. You can just say manage device, and it should give you a screen where you can type the address of your Pi, the username, password, and just click on test. So you can specify these details through this particular interface. And eventually, what you would do is you just say build and run, right? So this will start building the procedure. So let me show here as well. So right now you'll see it's starting to build, and at the end you'll see an archive as well here. So it's generating code into the folder that I specified it to. You see it's compiling. If there are questions, you can put it in the chat. So this is actually compiling the code, and it's generating the code. It's archiving so that you can deploy it as a ROS node. And it will eventually fail for me because I do not have a Pi with me right now. So you can see all the details here. So it's creating an archive for the model, and it says it's successfully done. Everything that needs to is just need to transfer this onto Pi, and it's trying to connect to Pi. So in the meanwhile, I can also show the archive which is generated because we generated the code. and it's eventually said that I have an error connecting to the SSH server, which is supposed to be our PI, and that's the reason it's not gotten through. But if you have a PI, you should be directly able to send it on to the hardware. So that's about our model on the Raspberry Pi. Now, let's say this had actually gone on to the hardware, right? And it would publish messages called /camera and /servo angle. We would want to understand, or we would want to subscribe to it, right? So let me show how you can do it on your desktop using this model. All we have done is use the subscribe block, right? We've just used a raw subscribe block. I am just basically unpacking and just displaying on the video. Similarly here, I'm just using the data field and just displaying it as the servo angle. So basically this will run as a normal simulation on Simulink. This will not go on the hardware, because this is what we are doing to visualize on MATLAB or on Simulink. So all we can do is we'll just have to click on run, and this model will run. But what's happening here is there's no topic called /camera or /servo. So that's the reason we are getting 0 here and a black black image here. If there was a topic, we would be able to visualize it, right? So with that, I think we'll quickly go to understanding. So you saw there was an archive, there was a file which was generated, right? So what exactly happens at the back? So you have the Simulink model. Now this is from the Raspberry Pi's perspective. This is the model which you want to, this is the ROS node we want to deploy on the Raspberry Pi. So we have the Simulink model. Then it will generate code, it will generate C++ code, it will archive it. It will transfer it to the target computer, right? It will extract to its Catkin workspace. It will compile it, and then it will eventually run it as a standalone ROS node. So this is what we did. We have a vision and control algorithm which we have designed to track a green colored object onto the hardware, and we are publishing camera and servo angle, which we are visualizing on our desktop, right? So again, this is just the video of the final task. I'm moving a green colored object, and you'll be able to see the servo angle over here, as well as the camera feed. So this is for us detecting and tracking a green colored object, right? Now let's say we wanted to let's say in our task, I think one of you all mentioned that typically we would want to tune the color, right? Let's say when it's running on the hardware, you would want to understand what the color is, and you'll accordingly want to tune so that it detects that particular color as the models are running. So this is an example of first we were detecting green color, but let's say we would want to detect and track a blue color. How would we do that? So this is just a small change in the Raspberry Pi model. What we are doing is we are subscribing here to a minimum RGB threshold and a maximum RGB threshold. The colors which we're describing, let's say green for us, right? Which I had shown it in the model. So we are not hard coding it, but we are getting it from another topic, which will see that we have published from the MATLAB or from Simulink to be precise. So what we are doing is we are subscribing to a minimum RGB threshold and a maximum RGB threshold. So you'll see we are deploying this on the hardware, and this is our Simulink interface. We have a minimum value and a maximum value. So right now it's set to green color, and what we can do is we can just run it. It's detecting green, correct? And what we'll do is we'll change this to detect blue. So we've just changed these values to detect blue, and you'll see when we, yeah, you'll see that it's detecting the blue color but not green. So this is just an overlap of the video which I created. You might see that Simulink is not running here, but it would be running at that particular point of time. But this is just an overlap to showcase how it would go about, right? So so this is about how you can deploy and work with Simulink as well as ROS together, correct? And what we did right now was we deployed it to just one robot, right? And this is where distributed systems come into picture, and this is where ROS helps. So you can have multiple robots communicating to each other with the necessary information, publishing the necessary information, or you subscribing to the information that the robot needs. So before we close, I would just like to showcase. I think you all worked on the TurtleBot 3, right? So this is just an example of, I think, the question that was asked. How can you detect something? So here we have an example where we are detecting these arrows and accordingly taking a call on where to move. Again, this example is available. Here you see the model here. Again, there's some state machines which are used, and I'll share these links in I think a couple of minutes. So just wanted to summarize some of the key takeaways which we had from the last 43 minutes as we have been talking. You can deploy algorithms on hardware from Simulink that actually generates a code that goes onto the hardware and it runs onto the hardware. You can definitely connect a remote ROS device, which could be a simulation, it could be a hardware, to MATLAB and Simulink. You can automatically generate, transfer, build, and run ROS nodes from Simulink to a ROS-enabled hardware. And you can use ROS to communicate messages to Raspberry Pi from your system. It could be to and fro, it could be publishing and subscribing as well. So this is what we saw today. And I think this is one of the most important questions, right? Probably you all are very new to MATLAB. Some of you all might have used MATLAB but are new to Simulink, right? And let's say I am new to MATLAB and I want to learn about MATLAB and Simulink, and then I want to eventually have an example like this built, right? I want to, let's say, deploy a ROS node. I want to work with let's say Raspberry Pi and deploy the ROS node onto the Raspberry Pi using Simulink. How do I go about it? So you can start off with MATLAB on RAM. Then you could go to a Simulink on RAM. Again, these are just 2-hour courses. There's a certificate which you get at the end. And once you're comfortable with these, I'll recommend you going through some videos. So there's a video series which we have on code generation, how you can actually generate code and deploy onto hardware. It also talks about a little different approach. We looked at the approach from the ROS perspective. It looks at it from directly deploying to the hardware, and again talks about a color tracking example. And then there are a lot of reference models which you can go through. So that's about how you can scope out your journey to learn more. I would also want to show how you can use the resources which are already available. I think there's a question. Great. So there's a question, I think, which is asking, could you please suggest any good course on MathWorks for ROS, which will be useful in doing image processing and also for multi-body simulation? There's another question on, can you please give a brief idea on physical modeling? And yeah, so someone said MATLAB on ramp is a good course. Definitely, it just takes a couple of hours and you get the certificate at the end, which is good, right? So to answer the other two questions, right, on what are the resources to start working on, let's say on image processing, on Simscape, on multi-body simulation, on ROS. So I think the best resource that can help you all is this page. I have just put it in the chat. It's called Student Tutorials and Videos. There are a lot of video resources here, and a lot of and all of them are with respect to students who are working on these examples. So you can, so there are some things for aerospace, there are some things for automotive, but one thing that will probably interest you all is MATLAB and robotics arena, which is specifically designed for students who are working on robotics. There are a lot of videos. First question on was I think on through, I mean, Simscape, right, on designing pneumatic systems. There are 3 videos here on simulating pneumatic actuator robots, and these are the videos which, the blocks which I showed, the 3 blocks with the team Automate KJC and DJC, they had all referred to these videos to get started. So these might be a very good point for you all to get started with Simscape and Simscape multi-body. So this is one. Another one which you I think asked on ROS, right? So there's this there'll be more videos which will come with time, but here is one video on mapping mobile robots and UGVs, and they talk about ROS enabled systems, how you can use MATLAB and Simulink. So this is in terms of 2 of the questions that came in. I think the next one was on image processing. So there are a lot of reference examples on how you can use for obstacle avoidance, just using camera. There's more on deep learning, working with YOLO V2. A lot of you all said you all are working with NVIDIA Jetson. How you can use the same approach, just working through deep learning algorithms, just clicking a button, generating code, and that eventually going on your NVIDIA Jetson. So that's one. But before you go to this perception, because they are a little more, let's say, advanced in terms of understanding, it's more application specific. If you would want to just get started, there are these tutorials at the bottom. So you see there's something called as Making Vehicles in Robots C, and there's a tutorial on there are 3 tutorials in here which talk about basics, then image segmentation, feature matching, and so on and so forth. Another question I think we have had is on physical modeling. How do you import CAD models? You can find it in the physical modeling tutorials, right? So if you see the syllabus, you'll be able to see how you can import CAD files. Along with that, there's the example which I showed today is here. It's called Deploying ROS node on Raspberry Pi. Again, there are files associated with this. It's called Object Tracking using ROS and Simulink on Raspberry Pi. So you can definitely download and start working with it. So I'll just put the link of this example in the chat here. So I think I have hopefully answered the questions that came in, but the videos, the page that I shared, right, that has all the videos to get started on different topics. So you can definitely have a look at those. Again, just highlighting, it's called MATLAB and Simulink Robotics Arena, and there are videos on modeling, perception, ROS, and robotics education. And there's one MATLAB, awesome MATLAB robotics repository on GitHub, where you can find all the resources, all the examples on robotics. And we also have a Facebook group called MATLAB and Simulink Robotics Arena. You can ask your questions there. If there are any issues that you're facing, any resources that you want, you can definitely ask us on the Facebook group. So you can go to Facebook and just type MATLAB and Simulink Robotics Arena. You'll find, you can request to join the group. And let's say you're working with these tools, you're working with these examples, and you have certain issues, you can just email us at roboticsarena@mathworks.com, and we will be able to, help you all out, point you all to the right resources, or if there are issues, we can help you solve those. So please feel free to reach out to us at roboticsarena@mathworks.com. Oops, I think there's the box is moved a little, but let me just actually take you all to the website. So we have a website for, we provide complimentary software to all the teams who are part of National DD Robocon. So you can just scan this code, or you can just type in this particular link, and you'll come across this page, and you can just request for software. But let me just do it. So you can just type National DD Robocon MathWorks, and you'll get the first, typically get the first link. You can just click on it, and you'll come to this particular page. You can request for software. So these are all the tools you'll get. Once you click here, it is either the team leader or the faculty advisor who has to fill out this particular form and submit, and all of you all can access the MathWorks tools. So you can definitely request for MathWorks tools, as you all are part of National DD Robocon, and the page which I mentioned, right? It's listed here, and there are a lot of other resources which are on this page. So definitely this is something that'll come of help. Just wanted to showcase the how-to videos, and there are, you all mentioned, right? There's an you all would want to, let's say, work on a PID controller, tuning a PID controller. So there are videos on how to automatically tune a PID controller, how to interact with Simulink and hardware. So there are a lot of videos which are available. Please do check, and there are questions you can just write to us at Robotics Arena, or you can join the Facebook group and ask us questions there. And this is the code. And again, just a summary. There are a lot of videos available. All of you all have access. All of you all who are registered for National DD Robocon can request for software. Please do to request if your institute does not have a campus-wide license, or if you don't have access to the MathWorks tools. Again, there are a lot of nice blogs that teams have explained their approaches. So you can definitely have a look at those as well. And if you would want to stay connected, you can connect with me on LinkedIn as well. We keep posting some interesting content, interesting videos and examples. So definitely stay in touch, and you can request again for the license. I think with that, I am done with the content I had to talk about. Any other questions that
Thanks,
might have?
Gayatri. I think you have nicely covered all the important things for the Robocon. There's just one more question. What are the file format for supported in Simulink for importing 3D CAD files for simulation?
I think I'm sure it supports .stl. I do not know it off the shelf, but there's definitely a documentation page which lists all of them. If you all can, there are a couple more formats as well. There's in fact a very nice blog which is written on how you can import different parts into Simulink to put it together. Dhananjay, if you can just probably email us at roboticsarena@mathworks.com, we should be able to take that question.
Okay.
I think there's one more question. So you can just request for software. It's complimentary. Your entire team can use it. You would not. It's a complimentary software. So you can definitely request for it.
Thank you. Thank you so much. Is there any more questions? Otherwise, you'll get a wonderful information about how to use MATLAB and Simulink along with the ROS. I think that's a good learning for all of you. Thank you, Matri. I think that's
Thank you.
a really wonderful session. Thank you so
Thank you.
much.
Thank
Thanks
you,
for
Dr.
your
Jha.
time.
Yeah, I'll just stop. I'm not able to actually stop sharing here. It's okay.
So over to you, Venkat, now.
Yes, sir. Thank you very much.
Thank
you,
you.
Matri,
Thank you.
for the wonderful lecture. And thank you, Sunil Jha, sir, and Mr. Kalhar for the introduction to ROS and the demonstrations. So now we are moving to the interesting part of the session, the day, that is the presentations by the participant here. Let me show the screen teams again, once again. Yeah. So here we have 18 participants in this program. The first group consists of Kaivalya, Gauri, and Sakshi. So I request them to switch on their camera and the presentation. They will be presenting what they have learned, and we have given a task yesterday. So they'll be presenting on that.
Yeah, Venkat, just keep track of the time so that we'll be finishing each team in 10 minutes.
Yes, and stop sharing.
Sir, actually, we are facing an issue importing some files. Is it okay? We just delay like 10 minutes, please. You can take the group for the time being, if that's possible.
If you have prepared any presentation, show it. It's
yes,
not
sir.
No need to.
It's still on. It's still a work in progress. So that's why. Just 10 more minutes, and it would be done.
Okay, then we'll go to batch 2.
Thank you so much.
So batch 2 is Shreyas, Rakesh, and Himanshu.
I think they were posting messages, no? Whether they are available or not, I'm not sure.
They are not in the.
So you just go next, third.
Third batch is Sai Krishna, excuse me, Divya, and Sri Ranganath. Sai Krishna, Divya, Sri Ranganathan, please unmute. Divya?
See, if you are in a meeting, at least you should respond.
Yes, they are in a meeting and they're not responding. She will be presenting. Sri Ranganathan?
Maybe they have switched on and left somewhere.
Yes. So then I'll move to the next team. That is Mohit, Yash, and Asmin.
So as I mentioned, those who are not making presentations, not available, they are not eligible for completion certificate for this bootcamp. So those who are not coming forward, they are not eligible for the bootcamp certificate.
So anyone is ready with the presentations? Please.
Yes, sir.
Up. Yeah, kindly present. You are Dhananjay.
Yes, sir. We have group number 6.
Group number 6, Pradeep, Tripathi, Prince Panta, and Dhananjay Arne.
Yes, sir. Could you please just give me 1 minute? So I will set up my presentation.
Yes.
Okay, sir. So I think, so just a minute. Yes, sir. I think my screen is visible.
Yes.
Okay, sir. Yes, sir.
Please
Prince
put
and Pradeep, are you here? Yes, sir. I will put it in presentation mode. I think it's visible.
Yeah.
Yes, please go ahead now.
Pradeep and Prince, are you there?
Yes, I am here.
Okay, Pradeep. Pradeep, hello.
Yeah, he is also visible, means in the participation list.
Yeah, you guys can make your camera also on so that we can at least have a interaction.
Yes.
So just a minute.
Can we start now?
So one of my teammates are not like responding.
Okay, no problem. You two guys can go ahead.
Okay.
Venkat, you just keep noting the names, those who are not coming forward.
Yeah. So
Yes, sir. Yes, sir.
yes, sir. So yeah. So good morning, everyone. My name is Dhananjay Arne, and I'm from VIT Bhopal University, pursuing my BTech degree in Electronics and Communication Engineering, specialization in artificial intelligence and cybernetics. And we are group number 6, and we are I'm Dhananjay Arne, Prince Panta, and Pradeep. So let's go with first presentation. So I'm unable to switch to because
Any issue, Dhananjay?
yes, sir, because I'm not too much familiar with Zoom, so that's why I'm facing some
Okay.
issue.
You can go step by step without in a presentation mode. That is also okay.
Yes, sir. Yes. Yeah, so that's our mechanical CAD model. Prince, please go ahead.
Hello everyone, I'm Prince and I will be explaining the CAD model. We have chosen the Omni drive in Yaks position, and as you can see in the slide, there are 3 Omni wheels, and they are aligned in 45-degree to the body frame. I will be showing the CAD model. I have developed the CAD model in SolidWorks as I was familiar with the platform there. Can I present?
Yes,
Can you see
yes.
my screen? Am I presenting?
Dhananjay, you can stop sharing so that Prince can make presentation. What he want to show?
Is my screen visible?
Yes, yes, we can.
So this is the model I have made, and this is Omniwheel. And for the section, I have used the rectangular section, not the aluminum extrusion, because since that was not available in here. I am from Nepal and I could not find that in the market. So, and we have used the rivet plates to join the sections, and the you can see here, this is the main frame, and from the top view,
Prince, how this motor bracket has been joined with this frame?
we have not used any bearing housing. It is directly joined because we had to do either the main frame or the motor
No,
bracket.
this was the challenge. No? We were discussing that in the mechanical part, no? Because unless you
Yes.
put a bearing and coupling, no, this will damage motor
Yes, sir.
very fast. Yeah.
Yes, I was familiar with that, but I didn't have enough time to
Okay.
manage all those.
So
So
you'll take care of that input whenever you do your final design.
yes, okay, sir.
Mhm.
And so I have also added a suspension system like the tractor suspension system over here. You can see this is the main frame, and this suspension frame in which the 2 motors are attached are.
Okay.
And one drawback is using the rectangular section is that we need to hold in that section, and in those portion the stress concentration occurs. So to tackle that, we will put some wooden inserts in the sections to overcome the stress concentrations.
Okay.
So this is from my part. Dhananjay will be taking on.
You can do the strength analysis as well as you go along, because you are using a rectangular cross section which is hollow. So you may evaluate, and you have prepared a kind of a good truss kind of in a structure. So please evaluate so that you can identify weaker link into the robot,
Okay, sir.
and then you can strengthen it up.
Yes, sir.
So Professor Sahai is also here. I welcome him for this session. So,
Thank
sir,
you.
you can also give some
Yeah.
comments
Yeah.
and suggestions to these people.
Sure,
Yes.
sure. No problem.
Yes, sir.
Go
So
ahead.
now I want to show you the Tinkercad model that I have made. So yeah, so the CAD modeling is complete, and now I have made a accident avoidance system in robots that will be useful to avoid collision between any objects using an ultrasonic sensor and the encoded DC motor. So I have made this type of a Tinkercad model, and let me show you the model in the Tinkercad. So I will be showing you how it's working. So I hope this Tinkercad model is visible to you, sir.
Yes, we can see
Yeah.
that.
So this is my Tinkercad model, and here what I did is I attached as yesterday, Kalhar sir has taught us about the encoder message and how do we have to encode and how do we have to set the RPM and all of that. So what I did, I integrated a ultrasonic sensor with that SR04, and with this I integrated the both encoder and the motor and the ultrasonic sensor. So here I wrote the code. I made the note from previous from yesterday's session, and I just follow the notes again, and I wrote the code same as the Kalar sir had taught. And after that, what I did, as I have some experience on using Arduino and ultrasonic sensors, so I use my previous knowledge to detect any object from this ultrasonic sensors. And here you can see the code. Here I write the distance and how much centimeter and all the programming I have wrote here. And I will like printing those in a serial monitor also. So let me run this code so you can see the output. So here I'm starting the simulation. So here you can see I've started the simulation, and in the serial monitor, the initial RPM of the motor is going around 130, we can say, as an average. So now if I you can see the object which is at 175 centimeter. And now if I reduce the distance between this, you can also see in the serial monitor the RPM is reducing. And as I'm going more towards the ultrasonic sensor, you can see the motor has stopped and going backwards. And as I'm increasing the distance, you can see the RPM is also increasing in the motor. So it will avoid any collision between the robot and any object. So it will our robot can safely move in the game field. So that's what I made in the Tinkercad. So hope you like
Good.
it.
I think it's a good work, Dhananjay. Nicely,
Yes.
whatever you have learned, at least you have implemented it and tested it. That's
Yes,
really
sir.
nice.
Yes, sir. So that's about the Tinkercad model. And unfortunately, Pradeep is not responding. I don't know why. But what he's supposed to do is he has to do the Arduino programming. And because I have also some prior experience in the Arduino programming. So we discuss yesterday what we have to do. And what I suggested him to do is to make a code of make a Arduino code to for the motor rotations for four-wheel drive. And then in the void loop, what he had to do, we had to first give the command to go up, and then he have to delay 1 second, and then he have to go right, then bottom, then left. So that's how he can make a rectangular shape of kind of thing. But I don't know why it is not responding. So that's what the Pradeep has to do.
Okay.
Yes, sir. And that's all from our group presentation. Hope you like it, sir.
Yeah. Thank you. I think at least you put some effort during this compact 3 days, and you have learned, and then you have tried out those concepts that has been explained. So
Yes, sir.
At least for the CAD part that you have attempted, and then this Tinkercad simulation. That's nice.
Yes, sir. Yes,
So
sir.
I have a question here. So that in the previous Arduino connection, minus 510, what was the motor output? What did they signify?
Sir, that's the RPM of the motor that we are
Mhm.
providing. Like that,
So-
what the how the shot will move.
So does it mean that it is going to the reverse direction, means robot
Yes,
is
sir.
backing up from the object?
Yes, yes, sir. -5 means it is going backward.
Okay.
Reverse
Good.
RPM.
So how many times you could discuss to complete whatever 3 items you people have planned?
Sir, we discussed 2 times. From tomorrow, we have we done 2 meetings at night and after the boot camp also.
Okay.
Yes, sir.
Okay. Good. Thank you.
Okay, sir. Okay, sir. So, shall I stop sharing?
Yeah, thank you, Dhananjay. Yeah, you can.
Yeah,
Thank you.
thank you, Dhananjay. To mention, Dhananjay is a ECE student, electronics student from VIT Bhopal, and Prince
sir.
is from Nepal Tribhuvan University, and Pradeep Tripathi is mechanical student from IIT Rupar.
Yes.
Good friendship
you, sir.
grown, right? Yeah.
Yes, yes.
Yes, sir. Yes.
Yes.
So 3 are from 3 distant places. So now I like to see who will be the next. So who
Kevalia
wants-
can come. Kevalia Pandya can come.
Yeah, Cavalier.
Sir, I'm asking my teammate about the PPT. My code is ready, but I think
Yeah.
she's still working on PPT.
Yeah.
I revert back
No
to you.
problem. So whatever is ready, you make a presentation. That's fine to go
Yeah.
ahead.
We're just doing that.
You make an oral presentation in that case if PPT is not ready.
Actually, sir, I'm Gauri Patil. I'm done with the CAD models, but they are on the other device, and this device doesn't have SolidWorks, so I'm having issue in exporting that. So
They can show from their system if required.
Yeah, not a problem. You can share. That's not an issue.
Sakshi, as I discussed with Kevalia and Gauri
Keep your
yesterday.
camera on. Sorry, keep your camera on.
Yes,
Yeah.
I discussed with Keval and Gauri, but Gauri is not responding yesterday. That's why I made a separate PPT.
Okay, fine. Go ahead.
Anyway, so this is also learning experience. In a team, if someone breaks, what happens? It can happen in a Robocon team also, right? So you have to prepare for contingencies. Yeah. Yeah. Go ahead.
So who will be sharing first? We can start with the mechanical design part. So whoever has prepared mechanical design can share first.
Go ahead, Kevalia. I will share next.
My mechanical design is prepared by Gauri. So I think if you can complete your PPT at your own pace, then I think by then Gauri would be switching the device. So that would efficiently utilize it at that time.
Please, Cavalier, you start sharing whatever you have on your system.
Sure, sir. Sure, sir. Yes, absolutely.
एक दूसरे को पुश कर रहे, तू कर हाँ? तब तक मैं बना लूंगा कुछ.
No, sir. It's already prepared.
अच्छा.
So what Kalhar sir taught us last night yesterday was to prepare the class motor and start using classes, and as it is extensively used, he told us that it was extensively used in his robot as well. We have tried to come up with the same practice. This entire class is what Kalhar sir taught us yesterday, and I have just added up on it. Actually, I could not make the 4 motors right now because of the limited inputs, limited GPIO pins of Arduino Uno. But if it is implemented on Mega, it can be easily made. But for the time being, I have created 4 motors and have will be working on that. Just give me a sec.
Kevalia, where are the limitation on the GPIOs? I can't see that because you have only connected 4 pins right now. No?
Yes, sir. But somewhat this L298.
L298. Okay.
Yes, sir. Because
293.
of that, I thought of creating another L293D, but I was not able to interface it well. So I thought if I can just code it, and I'll show you how my logic was. It
But
would.
then limitation is not from IO. No? IOs are still available.
Yes, sir. I think I just mistermed it.
Okay.
Sorry for that.
Fine.
Just give me a minute. All right. So in my code, can I reshare again? Because
Yes.
I hope my PPT is visible right now.
Great. Put in a presentation so that we can see better.
Yes, sir.
Yeah. It's good.
So, yeah. So the class which sir taught yesterday, this is exactly the same. What I thought was in what manner would the motors need to rotate so that we can achieve our simple goal of either a rectangular motion or circular motion or a Z-shaped motion or a S-shaped motion. Right now, I worked on rectangular and Z-shaped. Uh, so for the rectangular trajectory, what we are going to do is make our robot move forward some steps, which I have defined functions for each and every step, and each and every step is going to perform some task. Each and every function is going to perform some task and then revert back to some another function that would perform another task, and similarly it would iterate through 4 processes: moving forward, then turning right, then moving backward, and then turning left. So the function which was taught yesterday, that set PWM inside the class of motor, we have directly used that and created a loop to generate a rectangular trajectory in a way that it's a sort right now a square, and the logic behind it is the how the mechanism builds a motion determine the movement of the robot. This is a rectangular trajectory. The code is a little bit self-explanatory, but just to skim you through it, forward robo function moves the robot into forward direction. Stop robo function stops the robot for 1 second. That is 1000 millisecond. I have given the delay to it, and similarly backward robo function moves the robot into backward direction, and likewise leftward motion and rightward motion are also given depending upon the motor's spinning direction. So that's how we can perform the rectangular trajectory. Then for a Z-shaped trajectory, what I thought was we just need 2 functions. Rightward trajectory, we need to make a robot move rightward twice, and then a diagonal. For diagonal right top to left bottom, I have created a function where it shows that for this motion to take place, what we need is that motor number 1 and motor number 3 should move in reverse direction, and motor number 2 and 4 should not move or should not get powered. So what I did is first I made the robot move rightward some steps, then I made it go from right top to left bottom some steps, then I again made it move rightward. So that's how we can get a Z-shaped trajectory. That's all for from my side. That's how I encoded it here as well. But as there we do not have enough motors, and I have not connected them properly yet, I cannot simulate it right now. I'm really sorry for that. But
No, it's
that-
fine. Kivalya, whatever has been done, it's wonderful. So nothing to feel sorry. As you get more time, you will certainly be improving on what has been done.
Absolutely.
So at least you will be taking some of the learning in the boot camp, and for the real implementation, that is what we are looking at.
Thank you so much.
Thank you.
So as far physics, Cavalier, did the direction of the motion, did you understand, or you just followed what is been told by?
No, sir. No, sir. I understand how the mechanism wheels work. On how on in what physics they are actually implemented, and why why all the when I'm sorry, why all the wheels when move forward direction, why the robot moves in forward direction and not in any other direction. It's because
1 minute. For example, the central right, your robot direction is moving right, and
Yes.
the wheels are opposite. So did you try to apply a little bit of class 12 physics and see whether it will have a result in motion in that direction?
Yes, sir. I did doing that. I did do that. How do we know that is? I am not sure if you can see my cursor or not. Can you?
Yes.
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 So what happens over here is, I'll just take one simple example and then you will understand how it works. When when the motor number one moves forward, what in what direction the torque will be generated is in this 45 degrees. Because of the mechanism wheels design, and motor number two, when it moves in the forward direction, the torque will be generated in this direction. I hope you can see that. So when so their x's forces get cancelled, and y axis forces add up. Similarly, here as well, in the motor number 4, the outward 45 degree, it generates y axis some force, and negative x axis some force. And in the motor number 3 as well, y axis some force and positive x axis some force. Positive and negative x
Okay, you can stop. Thank you.
Thank you.
Okay, go ahead.
And from your team, Gauri and Sakshi, you have something to add?
I am presenting my PPT. Can I?
Yes, yes.
Actually, it would be preferred to have one PPT by each team. It's not an individual project.
Yes, I know.
Interaction was demanded, no?
Sorry for that, but I try. But Gauri is not responding yesterday. That's why. Can I?
Yes, yes, please go ahead.
By the way, meanwhile she shares, I'll say that Kaivalya is from Birla Vishwakarma Mahavidyalaya. He is a third year mechanical from Gujarat, Anand. And Sakshi Premchand Gadikar is from, sorry for that. She is from Vincent College, Nagpur. And Gauri Deepak Patil is from Cummins College of Engineering for Women from Pune.
Okay, Sakshi, go ahead.
Is this visible?
Yes, yes.
Good morning, everyone. Presenting before you is Sakshi Premchand Gadikar from St. Vincent Pallotti College of Engineering, Nagpur, Maharashtra. So let's move to our first topic, that is mechanical design of frame assembly. Here I have used a software Fusion 360 to make a basic structure of model, because as presenting from 2 days, I just make a basic structure of a model.
Okay, good.
So components we used here are 40 aluminum frame, aluminum profile corner, base plate, high torque motor, Mercanum wheel. Here I used 5 components to represent frame assembly of mechanical design. The basic of this components and information is that 40 aluminum frame slot is used for assembly. It's the most basic important component, and it's the most important component of a board. It is a strong and steady.
Sakshi, as we were discussing, I was giving feedback. Na? Directly coupling the wheel with the motor shaft is not a good idea.
Okay.
That is where we have explained you detail how the whole drive assembly has to be prepared. There has to be a proper bearing support for the shaft. There has to be a flexible coupling in between. Then only it will be a good design. Otherwise, as I was saying, because any kind of perpendicular or lateral loading on the motor shaft will damage the bearing inside the motor.
Yeah, but as a basic, I had just proceeded.
Okay,
but
fine.
I will improve it at a good point.
Okay.
One suggestion here for all of you actually, if you start saying that, okay, as a basic, I would like to practice the incorrect thing, you may continue with this. If you say from today, for the sake of analogy, I will say A is pronounced as ba, right? For example, right? So you'll keep doing it. You do less, but do correct things from the very beginning. It's a good habit actually. Otherwise, you end up using the same thing. Continue.
Yes, sir. Then second one is a aluminum profile corner, and here we use this for the whole chassis assembly together for providing support to the model. Then we use a base plate. Here base plate is used for a hold a high torque motor, which is used in a.
But we can't see anything. Nothing is coming. What you are explaining.
Yes,
We just see a simulation of structure making, that's all. No, this is fine. The next slide.
Video is not playing.
No, video is not playing.
From here it is playing.
Okay, so we can't see that.
You have to share the full screen. That may be the problem. Or you have to duplicate the screen, no? Either way. It may be showing extended screen.
I shared a full screen, sir.
So then you have to duplicate also. When you go to the presentation mode, go out of the presentation mode and try it again.
You have to, when you share your screen, there will be an option, share your entire screen and share your audio video. So these
We'll
are
try to finish in time because this is getting too much time. So let's try to cover as early as possible.
It's playing now.
No, you have to stop sharing first. Then only we can see that.
So, will your next partner will be presenting something, or we can move to the next?
She's not there, I think, no?
No, sir, I am there. Just give me 5 minutes more.
5 minutes is too long, may not be possible, like said,
So
maybe
we'll
have to go to the next.
Meanwhile, they come back, we'll move to the next team if they are ready. So anyone else from the group participants, they want to?
Group 4, 5, you read out the names so that we can know at least those who are available.
Yes, sir. So Mohit, Yash and Ashim, Dhwani, Shashidhar, Aditya Rao, Ganesh Rao.
Sir, I am the only one present from my group here. I tried to contact them. She is sick and other one is not attending the sessions.
Okay.
So I was alone.
But you can make presentation from your part?
Yes, sir. I have made a CAD assembly in the future.
Yeah, so after this, we can take up yours actually. It's fine.
Okay, sir.
Sakshi, just try to finish it as quickly as possible.
I am playing video from here, but it's not showing there.
Yeah, no issue. Anything else you want to show?
Yes.
Yeah, just go to, that's good. So just explain this, what you have done.
Fully functional differential drive using 2D. That is second topic for our presentation. In the ThinkerCAD, we have created a simulation of an electronic circuit. This is also video, but it's not literally playing from here. It's
Okay,
playing,
no issue.
and it's not showing. So here we this one that was in black. It is a motor driver which is L293D, which is an external supply battery which is controlling using Arduino UNO, which is connected with Arduino UNO. Then DC motor and motor driver are being given ground connection with a black. Then when these black wires are providing a ground connection to the DC motor, and red wires and blue-green wires are used for, mainly red wires are used for the power supply to the motors and driver to Arduino and battery. We use battery for more good connection, because if we use only Arduino, it get some disconnection. So we use this battery too. Then blue and green wires are used for giving inputs to the driver. So which are connected, wires which are connected to Arduino, blue and green, it's are used for giving inputs and run motor clockwise and anti-clockwise. If I show this, but it is not showing there. So
okay. Go ahead.
Sakshi.
Next.
I have a question, Sakshi.
Yes, sir.
So once go back previous slide.
Yes, sir. Yes, sir.
So here I see that you're putting 5 volts from the Arduino, the red line, okay?
Yes,
and,
yes.
And ground is also going to the bottom of the breadboard.
Yes.
And same breadboard red line, if you see at the other end, there is one more red wire going, which is going to the 9 volts of the battery. And
yes,
similarly your ground. So you are connecting your 5 volts and 9 volts. How this would work?
5 volts and okay, waiting. Then we it is because 9 volts battery is
No, this will damage Arduino board actually. You should
9
not
volt
give
battery.
9 volt to the Arduino by any means.
It will damage.
Yeah.
It will damage, as well as why you are connected to 5 volts here. These are output pins. It will provide a 5 volts output. So there will be definitely an circuit issue here. So for what purpose have you connected this 5 volts and ground here?
Because I think it will work slowly, highly, and very frequently. So I just added. But
no, power to the Arduino should be given by that USB that has been mentioned. These pins, what Dr. Venkat is explaining, is to take out the voltage from the board actually. And I think you are trying to give a voltage to the board through that.
yes,
So you are giving a 9 volt, that is not required at all. So this red and black wire that you are connecting to the Arduino, only black is required to make this common ground. Otherwise, red is not required at all.
If you want to give supply to Arduino, can you see wherever you have connected the red connection at 5 volts, the leftmost pin is there is a VIN. You can connect it there so that supply to Arduino will come.
Yes.
Yes. Okay.
Okay.
And on add-on,
yes.
you can only supply high voltage to the L293D on pin power 2. Sir, can I share my screen and explain, or it's okay?
No, it's okay, color. So
okay.
I think you can directly communicate verbally what is the issue. So that is fine.
Okay. Yeah. So there is a pin called power 1, my bad, power 1 on the L293D. You can only supply the high voltage on that pin. On the power 2, you have to supply 5 volt from Arduino.
Yes, logic voltage should be 5 volt. Yeah. So I think that there's a issue in mixing up the 9 volt and 5 volt understanding that need to be refined.
Yes, sir.
But anyhow, it is a good try. Her background is information technology. She had tried to do that one.
Good.
That is great.
So simulation tools are good in that sense. That's how, without damaging the physical hardware, at least you can at least verify the designs here itself.
Yes, sir. Yes, sir.
Mhm.
I will. And this is from my side. Thank you.
Okay. Thank you, Sakshi. Thank you.
But whatever is said to you, did you try simulating and see that okay, something abnormal is shown in the plots?
Yes, I will. I will take care of that, and I will just simulate that what sir has told me.
Okay. Oh.
But color, this will not point, this Tinkercad should not point it out because it was generating some alarms, no? In that case.
Yes, sir, I will.
It should point it out.
Ah, that is
No,
what.
maybe not. When she does a simulation, that time it might show up actually. She has not done
simulation
that
has
yet.
not done, it seems. No? That is
Yeah,
what
that's why it is not that intelligent yet. While correcting itself, it should point it out. No, one day will come to get that kind of signal also. It will not let anyone connect there, right? Yeah, okay. Go ahead.
Thank you, sir.
Thank you. Thank you, Sakshi. Gauri, are you ready now?
Yes, sir, I'm ready.
Okay.
I'm not having SolidWorks in this device, so is it okay if I share the screenshots?
Yes, yes, yes.
Okay, sir, thank you. Is it visible?
Yes, yes, I can see
Yes,
that.
yes.
So this is the base. For the motor assembly, we have used motor, coupling, bearing housing, and the MS shaft. This is mechanism wheel, and this is our whole assembly.
Okay. So you have not shown that L bracket to mount the motor to the frame. How the motor has been fixed up to the frame?
We connected the housing and extrusion bar. Like we created the.
You directly use mounting by housing itself, no? But that cannot
Yes.
happen. No? Motor will be in hanging state, no? Then because your coupling is flexible actually.
No, motor is attached by LO. I'm not showing that.
That is what I was asking. No? How the
Yes,
motor is fixed to the frame.
You can show.
No, sir. Right now, I'm not having the SolidWorks.
Yeah, this is the just a screenshot, so that is how it is
Yes,
not
sir.
coming.
Achha.
And this motor should go on the bottom side of the frame. No? It appears that you are placing on the top of the frame.
Yes, sir.
So that also should be taken care of.
Yes, sir.
Okay, thank you. Any other input for Gauri?
No, sir.
Okay, fine. I think that's.
Go ahead, next team.
So we'll go with the next. Aditya.
Team हो गया, दो team हो गया, right? दो team हो गया.
Who is going to make a next presentation?
So we have here Mohit's team did not respond, and Aditya is.
Yes, sir. We can present. Duffer can present.
Yes.
Yeah,
Please go ahead.
अब message चला गया, अभी आ जाएगा वेंकट. Everybody will come. Sunil message has gone now, no? No
Yes.
certificate unless you make a presentation. भागादौड़ी आएंगे सब.
Yes, you can start.
Yes, sir. He'll share the screen once and then I'll start. Okay, so this is a CAD model prepared by my team and me during the boot camp. So this is just the way that we have seen you guys doing the modeling. Just we have done it in SolidWorks. So we have used the same aluminum extrusions that were used with the mechanism wheels with high torque motors and coupling and bearings. These are the different views of the CAD model that we have prepared. And this was the bottom view of the CAD model. As you can see in the isometric view, that is in the center. And this is the left view, the third one. Next slide. This is the right view and this is the front view of the CAD model. So
Again, this mounting of motor is not coming out clearly. How you have mounted motor?
Sir, the plate that was to be attached with motor and the coupling that went missing during the assembly part.
Okay.
That is why it is not actually showing the plate of mounting. But actually there is a plate between the coupling and the motor itself,
Right.
so that the bearing can rotate.
Yeah, certainly.
Yes, sir.
Okay, good.
That's all from my side.
Okay, anything from your team members? Who is along with you?
Yes, sir. There is Mohit and
we'll carry on the next slide.
Yeah, please.
So this is the Tinkercad model we have done. We have inputted 4 motors. We have connected the battery through here, positive, negative. And actually we have at the time of creation, we took the screenshot and put it here, but in the model, we have not done it here. Like we have removed the plus 5 volt and ground here. I will just show you the simulation.
You have corrected
So
now,
as
or
you
it has been done earlier? So again,
No,
the
we
same
have
power
corrected
supply
it.
issue, no?
Yes, but in practically also we have done it, and
Okay.
we have not connected the plus 5 volt to from here to the battery, so it won't the Arduino won't go bad. So this is the simulation. As you can see, all the motors are running, and this is the code we have inputted. I will show you that in the
But
slideshow
what
too.
color is mentioning? Have you taken care of that part? The logic of the L293D should be driven by 5 volt. So have you given the 5 volt to L293D?
Yes, sir. We can use the buck converter to do that. But in
Can
the
use,
Tinkercad,
but right now it's a 9 volt you have given. No? That is the issue.
Yes, but in the Tinkercad model, there is no buck converter.
Okay.
Sir, he's providing
through,
9 watts of power too also on the L293D. I think that's
in the practically we have done in the real, we have used the 12 volt battery. I will show you that to that simulation too.
No, again, another point is that how you are driving 2 motors from one, because this is
like
dual H bridge.
front right. Yes, we have synced the front
you
right
place
and
2
back
motors
right.
in parallel. No? You place 2 motors in parallel.
Yes.
But that may not be a good practice. No? How you are then, which type of wheel you will be using with these motors? Because once you put them in parallel, they will be running.
I will
at
show you the video.
speed,
No, like what we have done, we have synced the front right and back right motors. Let me just show you the video. So, but we were only able to simulate the circle one. That rectangle one was not working really well. So what we have done is we have gone the high input to one side of the motor and low input to this. Means this will be not be working. Only
So
this side.
we are
So it will
operating
execute
motors
the
in
circle.
pair. Na? That is what I'm saying. You are operating motors in pair.
Yes, correct.
Okay.
So this is only unfortunately we were only able to execute the circle. And this is the components
case, 2
we have
motors
used.
may not be required. Na? In that case, 2 motors may not be required. Na? It's almost like a differential drive kind of a system.
Yes. So these are the components used, Arduino Uno, and we have used the L29010 motor driver. In the Tinkercad, it was not available, but we the real life application we have to put that. Then this is a 12 volt battery supply and 4 DC motors. As you can see, these are the motors. And this is the code. So we have input 2, 3, 4, 5. So 2, 3.
It's okay. I think detailed explanation of code is not required because you are showing functional. That is fine.
Okay. So that's it. What the slide? This was our slide.
Okay. And this hardware which you are showing right now, when you built this hardware?
Which hardware? This
one, yeah.
We have built yesterday.
Okay.
Can you repeat?
No. I'm just saying, is this already available with you?
Yes, it is available now.
Okay. No, have you built in these 3 days or you already have it before it? Actually, that's what I'm asking.
No, we built it yesterday.
Okay. Good.
So while building, did you discuss among yourself or you alone did it on behalf of the team?
No, after you submitted a task, then we discussed it and built it.
Okay, good.
We have a team.
Okay, very good.
So can you go to the
Good,
first
Ajay.
slide?
Thank you.
First slide, because there is one issue in the wheel assembly. So did you take care of the wheel configuration so that they rotate exactly?
Yes, sir.
No, the right hand and left hand side, that's the issue actually here. No?
Sir, the right hand has the right mechanism wheels and the left hand has left mechanism wheels.
No, they should not be like this. No? So if you have noticed what Kalar was explaining yesterday, the direction of the wheels will be opposite basically.
Yes, sir. Actually, the thing is the motor number 2, go back. This motor number 2 and motor number 4, you see this, its direction is not same. No? Actually, the roller direction is motor number 4 is going outward, and so you have to interchange the motor number 3 and 4.
Correct. That is what I'm saying.
Okay, sir. Yes, sir. Yes, sir. I got it. We have to interchange the two motors.
Correct.
Yes.
Yes, sir. I'll do it.
Okay.
Thank you. Who is next now?
Sir, I will be.
Aditya.
Is my screen visible?
Yes, I can see.
Yes, sir, I am from group 5. Sir, I call both of, means I call her Dhwani, my teammate, but she was not here due to she was sick, and the Shashi that is not attending session from last 2 days.
Okay.
So I was alone, and I tried to, means I'm from electrical background. I can easily get it on with the Tinkercad, but I tried to get hands-on with the Fusion 360. So I just wanted to go with the CAD assembly.
Yeah.
So I have done it. This in Fusion. I have made a simple CAD assembly. So
nice. I think this is good. This is also looking good.
Yes, sir. Sir, there is a, means while doing this CAD assembly, I have managed to do this with the help of YouTube and some resources. But there was a problem while fixing the bearing in it. Means I cannot find out a joint between that, and it's not possible for me to go with the joint. So I have simply built this using a motor and a Omni wheel.
Okay.
So this is my presentation. This is what I did.
So you have directly covered the wheel again. So that is what
yes,
you
sir.
Yeah, because of the bearing you didn't find that.
So bearing also, and I don't know the parameter of the shaft to how to go with it within the short time. If I got my time, I will be ready with the Tinkercad and whole Arduino code with the by 4.
Yeah. So carry on. That is what our suggestion, wherever you have left right now. Certainly within 3 days, if you have not done that, please continue implementing this and then share with us whenever you complete.
Yes, sir, definitely I will going to do.
So Aditya, I have one question.
Yes, sir.
In the upper view, from the center to the wheel, what is the distance?
Sir, I have just joined it, sir, because the distance of that side, this is fixed, sir. This is fixed. This is I have calculated it.
Whatever you are showing, any dimension?
Sir, it is approximately 100 mm.
110.
110.
Okay.
Sir, bigger one is 200.
Okay.
So I have built just a hexagon and a triangle and fixed that hexagon in it while doing the calculation.
Okay.
These Omni wheels, the rollers are orthogonal, perpendicular. No, was it there in the software, or you have chosen that way?
No, sir, I have chosen that.
Achha, so now the model is ready-made available in the software, or you have to create the wheels also?
Sir, I have to create, means I have to, means
okay.
I try to get the extrusion, but it's not going well. So I have to create that whole extrusion, aluminum extrusion, shown
Oh,
by Anil
wheels.
sir
What
in
sir
that
is
video.
asking about the wheels.
Wheels.
Sir, wheels I have to get imported from.
Achha. So why did you choose
It's really
90 degree? Why not 45 as shown, or why not some other angle maybe?
sir. Sir, I want to go with the third, means omni wheels, that three wheel, because I want to do a coding with it in the next few
No,
days.
three wheel is okay. The rollers around the periphery of the wheel, you kept it 90 degree to the wheel axis, whereas in the training, Kalahar has showed 45 degree. No, the wheel we have
Sir,
used.
these are at 120 degree apart.
Not that one. The rollers, the Omni wheels has a rollers and the periphery. Am I right?
Yes, sir. Yes, sir. Yes, sir. That Magnum wheel or this one?
Mechanism wheel, yes, or Omni. That's called Omni wheel actually also, no?
Yes, sir. I try to use Omni wheels due to having.
So that Omni
means
wheel,
I cannot.
that Omni.
Yes, sir.
Yes, that is perpendicular. The roller axis
Yes, sir.
is
That is
perpendicular to the axis of the wheel.
Yes, sir.
But during the training, the wheel we have used, the roller
Magnum
is
wheel.
about 45 degree to the wheel axis of rotation. Am I right?
Yes, sir.
So why did you choose 90 degree, not 45 degree?
Sir, I want to go with the Omni wheels because this can be implemented in my team also, sir. And we do not have the access to the Magnum wheels right now. So I try to go with the Omni wheels and put the same, means this whole idea in my Robocon 2022.
Okay. For your information, that is also called Omni wheel. This is also Omni wheel. It is just a matter how you place this. No? Omni means any directions. No? With this wheel, you can go any direction. With a conventional wheel in the car or in the bicycle or motorcycle, you cannot go in the sideways. No? It is just a matter, no, whether it is 45 degree, 90 degree, 60 degree, it's a choice of the designer. And mechanism is a Swedish invention, and Omni is the term used by the Americans. No? But all in the family of Omni wheels. You should know that thing. Okay.
Okay, sir. Thank you, sir.
Okay. So go ahead. Next team.
From team 2 and team 3, are you ready?
You can read out the names, those who are from team 2 and team 3.
Sri Ranganathan is speaking out. Sri Ranganathan?
Your voice is not coming. We can't hear you.
From team 3, Sai Krishna Teja, Divya Kirtana, and Sri Ranganathan. And team 2, Shreyas, Rakesh, and Himanshu.
So team 2, I can't see anybody here.
Yes, sir.
Team 3, at least few people are there. So if they can make some presentation. So only Sri Ranganathan is there. No? Anybody else from team 3?
So I think they are not ready, sir. I think we had to.
It's okay. We are almost at the end of the presentation slot also. Okay, you are presenting. Okay, then please share your screen and then present. Ranganathan, you are not audible at all. So either you have to join from mobile or some other device to speak up.
Yeah, your volume is not high. Very low volume is coming. Come closer to this. Yes, yes.
don't have a CAD source. I have decided in my institution. So shall I show the images?
Okay, okay. Continue.
Yes. So this is I have designed the CAD model, the base CAD. I have used a mechanism wheel, the whole mechanism wheel, and four I togged motor, one C clamp mounted.
Your voice is very low. Can you come close to the mic or do something better?
20 spots and 13 spots are mounted in the base aluminum base. This is the model, CAD model, which I have designed it.
Okay, go ahead.
Yes. The same design I have make some prototypes and all for the event last time also.
Okay. But in this CAD, you have not shown other views actually. So we can only see that some part of the model. We can't see the complete design.
Okay, sir, sure, sir, sure. Sir. This is basic circuit which is connected to DC motor with one drive and Arduino connected.
But then you are operating these motors from the Arduino, no? That is not possible, no? Unless they are very low torque motor and very small motors. We
Yes,
don't
sir,
power. We don't
it's
power
5 volt
motors.
DC motor.
Hmm.
One drive is connected to that.
Hmm.
This is the images and the concept that we have. The code is not available now. So we have made prototypes by learning and using the concept of mechanism. The base wheel 1 and 2 and 3 and 4 are which is move the forward directions. The base board will move with the forward directions. If the front one and A back end are moves opposite directions, it will turn off with its right directions or left directions. If we have to turn off left side wheel, if move a forward direction and the other right side wheel moves backward direction, it will turn at the position opposite directions.
Okay. Thank you. We still there. I think a lot of improvement required in what you have attempted. So hopefully whatever you have learned, you understand the practical way of implementing the things and will incorporate that in your final designs.
Yes, sir.
Thank you.
Hello, sir.
Venkat, anyone else?
So one more team is there.
But nobody is there. Huh, to
Yes.
At the present, if they're not present, then just forget it.
Yeah. So we'll continue with our program. So I think we are at 12:06 now. So.
Hello, sir.
Yeah, Aditya.
Sir, how many motors can we connect to the Arduino Mega? Because yesterday we have seen that the communication serial port we can only connect up to the 4 motor.
No, so how you are driving the motor with the Arduino Omega, no, that decides. So right now you are using two different motor drivers, or how you will be trying to do?
Sir, actually we are using 4 drivers for 8 motors.
And 8 motors?
Yes, sir.
Okay.
So do we require to shift from Arduino Mega to STM32 discovery boards, or we can easily have it?
Yeah,
within
Arduino
the
Mega
Arduino
2560, what we are showing is having a lot of IO pins that can be used.
Sir, about the serial communication pins that shows by the.
So are these drivers being driven serially, or it will be through the direction and the PWM pins?
So direction and PWM pins.
So then why you are worried about serial? See, it's
sir, we have to
simply
control the
communicated through IO, no?
rotation.
Pardon?
Yes, sir.
No, why you are concerned about the
Sir,
serial communication?
Sir, yesterday sir had shown the serial communication between the motor. Then what is the difference between that two things?
No, color where you have shown the serial?
Sir, Venkat sir shown that while connecting, means they have connected the drivers to the RX TX pins of the communication serial port of Arduino Mega.
Venkat, can you respond to that?
Sir, I did not. Once again, can you repeat, Aditya?
He's saying you are showing some serial communication between the Arduino and some other board, no? Is that right?
No, it is serial communication to ESP and Arduino for the Bluetooth connectivity to the PS4. It is not
Correct.
for the motor.
Correct.
Sir, but the channels you have said enable A, enable B to the RX TX pin of the communication port of Mega.
Sir, shall I answer this?
Yeah, Kandar.
Okay. So they are serial pins as well as their digital IO pins. So we have used those pins because 4 of them are interrupt pins on Arduino Mega. We are not using serial communication from those pins. We are just using interrupts from that pin. We do not need serial communication to control the motor unless the driver is controlled via serial protocol.
Yes.
Okay, sir. Okay. Means if we try to control the RPM means using the Hall sensor, we have to go with the serial communication.
No, you don't.
And motor feedback.
No. It all depends on how your driver get interface. No? See, your motor driver should communicate then on serial with the controller board. Then only you will be going with the serial communication. Otherwise, most of the drivers are taking PWM and the direction input that can be given with the simple IO pins, and the encoder can be taken onto the interrupts.
Okay, sir.
Okay.
Thank you, sir.
So thank you, everyone. I think we'll go to the next segment of the program. The final participation was very. Participants are very active and they have presented their work. So before we close, we wanted to demonstrate the robot we have with us. So Paras and Pankaj are in the play field. So they will be showing us the robot. Okay. Sure. Are you ready? Yeah. Yes. So
have you shown in the beginning, or this is first time you are showing to them?
No. We have shown in the beginning.
Okay.
This is for our yeah. Yeah, हम देख सकते हैं. So let me yeah. Can you see the screen?
Yes, we can.
Yeah, sure. We have increased the test how it will behave.
So good.
How are you controlling?
PS4 through the wireless remote. Yeah.
Okay. Oh, pretty fast.
Good, I think. Yeah, it's working very nice.
Yes, sir. What is at the center? Money to be deposited at the center? Venkat?
Yes, sir.
What is at the center? There's some box to put some money there.
Yes, sir.
Collect subscriptions, right?
Yes, sir.
Robot beggar or robot collector. Okay, it's very good.
Good, Venkat. I think let's go with the next part of the session, so that we'll come to the closer now.
So we'll just a minute. So we'll take some. We want to take the views of the participants, so they can give their views.
You can share the
If they
feedback
need
form
further
also with them.
suggestions, they can always communicate with us. So the group will be still intact, WhatsApp group. So anyone from the participants
And feedback
can you
form, whatever.
give
Sorry,
your feedback or comments? How did you feel? What did you learn? So I'll call out the names quickly, so you can just give your comments. Aditya.
Yes, sir. I was going to speak on that. Sir, what I thought and what I get, it's totally different. Means I
Okay,
thought you will
Aditya,
provide.
are you around or?
Hello, sir.
He's
Yeah, can you
talking.
speak?
Venkat, he's talking. Be louder. Yeah.
Sorry, sir. Sir, what I thought and what I get is totally different. Means I thought you are showing us the in hybrid mode we cannot get this much amount of knowledge, but what I get is totally means I am in the stage that I myself tried to get hands-on with the SolidWorks and all AutoCAD Fusion 360. That's not what I expect from my side, but what I get is totally new, totally different, and it's so much exciting. And I want to continue in the field of robotics. I'm totally excited about what coming next to me. And thank you so much for this wonderful. Means I get to learn many about pneumatics, what sir said about the Arduino, about the board that I really don't know about the serial communication board, how that they work. It's totally new for me, and I'm so much excited to see what coming next.
What coming next is participating in Robocon. You will be learning 1,000 times more than what you think you are learning. Okay.
Yes.
So we look forward for your submission, your team submission.
Yes, yes, sir. We are doing.
Yeah.
We are on.
So out of 10, how much marks you will give to this program?
So there are only 10. There are only 10. If there is more, I will give it.
Okay, thank you. Yeah.
Thank you so much, sir. Thank you so much, Venkat sir. Thank you so much, Sunil sir, Kalhar sir, Paras sir, and everyone, SK Saha sir. So to guide us from this and to make it this in my whole 2 year, I have attended many more seminars and this, but I cannot get this much from any from last 2 year. I cannot get this much of amount of knowledge and practical hands-on and excitation. I'm really thankful that.
Thank you.
Sir, can we have the PPTs or?
We'll get back to you on that.
Okay, sir. Thank you, sir.
Just a comment here. Getting PPTs will make you obsolete, because whatever you learned, what is your brain captured, it will innovate on the basis of that. If it's a PPT, you think you have something, and your brain will not work anymore. So that's not very good idea. But anyway, Venkat will tell what is the plan.
Yes.
Okay, that will be. I will search on my own. Thank you, sir.
So next we move on to Dhananjay.
Yes, sir. Good afternoon, sir. And
please make yourself visible also. Venkat, also you can make your camera on. Otherwise, I will the only person looking on the screen.
Yes, sir. So that was a wonderful session, and I've learned so much of things. And I didn't study these things like Arduino and this ROS from this deep knowledge. And but one thing I have to say that the bootcamp is gone too basic. I supposed to learn more new advanced things, we haven't seen the Simscape multi-body simulation. That was I am looking for. But anyway, sir, the Simulink and the MATLAB and all the sessions that were going on, that was really good, sir.
Thanks, Dhananjay, because advanced sessions are always possible, but we have to consider the level of everyone joining this bootcamp.
Sir, one more request that from next year, if you could please take the bootcamp a little earlier, so we can plan more things based on the bootcamp. Yes, sir. That's my only request.
Thanks. I think that's a nice suggestion. Maybe we will be planning more advanced sessions coming up also.
Yes, sir.
Just
You
Yes.
see,
a
for
start, yeah.
for the
Good afternoon, sir.
Steamscape and sorry, 1 minute. For the Steamscape and other things, MATLAB has sufficient, tutorials,
Yes, sir. Yes.
and there are online courses are also available. So you may try
Okay.
those things as well. Yeah. Okay.
Okay, sir.
Sir, I also learned much a lot in this boot camp, and it helped me. And it also helped me a lot for the upcoming Robocon seminar for the Lagori concept.
May I know who is speaking?
Yeah. Pradeep.
Pradeep, me.
Yeah.
So it also helped me a lot and gave so much experience so that I can make a Lagori concept, Lagori for my upcoming Robocon 2022 session.
Good, Pradeep.
Good. Good.
Miss Dhwani Agarwal. So, Kaivalya Pandya.
Yes, sir. My experience with the bootcamp was pretty good. I learned a lot. I mean, many new things came into picture. Many new perspective I thought of. I didn't even think of would help me help me for Robocon or not. Like analysis of material, and even I didn't know how MATLAB could help. But I'm thinking of switching to MATLAB as well. And ROS was a difficult framework for me earlier, but now I'm looking forward to exploring that as well.
How much marks you will give out of 10 to this program?
8.
8. Good. Okay. Proceed. Next.
So I have a curious question. So we all had here in the team. Are you in relations with our Mr. Kalhar?
His brother. His brother, I think.
No, not at all.
Okay, not even a cousin. Not even a cousin.
I really.
So much similarity, KP both.
Yes.
And also Kalahar has been so much thinking about the student community while we are framing the rules and regulations, right? Kalahar, tell us about what is here? what you have a comment here?
No comment, sir.
No
I don't know.
comments. So you are actually student friendly, not relative friendly, right? Okay, go ahead.
Go ahead, and we go to Gauri.
Okay, hello, I'm Gauri. So this boot camp was really helpful. As we know that robot can't build without base, and the base helps very much for traversing. I think the work we done is based on the base itself. So this boot camp helps us a lot, and I guess this will help in the Robocon competition for our team too. So thank you for this session.
So foundation is already made, right? Now you can have the rooms and the windows, etc.
Yes.
Isn't it, Gauri?
Yes.
So what marks you will give it to this program?
Yes, sir. Full marks.
A full marks, very good. Not more. Okay, chalo, good. Thank you.
Thank you.
Yeah, Mr. Mohit.
Yes, sir. This was a very means from this event we got many information and knowledge that we will be looking forward to apply it in the Robocon. Mainly the pneumatics part that we had a very big doubt. We got cleared on that, and also the base thing. Thank you.
Okay, thank you.
Thank you.
Mr. Prince.
Yes, so hello everyone. It was really a great experience in this bootcamp, and it was really beneficial. I got to learn a lot of things, especially being a mechanical student. I didn't have much knowledge about the electronics section, and this bootcamp gave me the opportunity to learn all those basics and fundamentals, and now I can take on my own and learn from the resources that you have provided. I would really like to thank you for this opportunity, and I give the A+ for this session.
Yeah, so with your participation, this program has become an international event. Thank you, Mr. Prince and Asim.
Yes, sir.
So, Mr. Yash.
Hello, sir.
Yes.
Yes, sir. I would like, first of all, like to thank you all for giving this such a great platform to learn the basics and to start a project. So this was a great experience for me and my team. So as you can see, my team is continuously working here, and they are all preparing for Robocon 2022. And we would like to thank you all for giving us such a great platform to explore our knowledge and some fields also. Thank you, sir.
Yeah, good to see all your teammates working together amid COVID, and looking forward to see you in Delhi.
Yes, I hope to see you soon.
Thank you. So, Sri Ranganathan. Sri Ranganathan is not available. Now I'd like to ask our members from the organizing team, Mr. Kalhar Pandya, the all-rounder.
Don't tell me that.
So please.
So it was a very good experience to see the younger generation of Robocon working very hard to get their hands on the base. Especially I come from the Robocon background. I'm participating in Robocon since 2020, and it is a very good learning curve for me also, from Robocon to IIT Delhi. Thank you so much, Sunil sir and Subir sir, for this opportunity. And yes, hope to see you all in the IIT very soon.
Thank you, Kalhar. And now, Paras.
Sir, I have a question. Sir, today because of Omicron variant, there is so much curfew in the cities like in Noida and Gurgaon and Delhi NCR. So how would the Robocon would happen in Delhi?
There's no more curfew now in Delhi, so don't worry about that. So the curfew things has been over now, and the things are improving, and hopefully we'll be having a good Robocon coming up.
So does the Robocon competition would occur offline or in online mode? Because in 2021 it was
You
completely
first
online.
build your robots, and then we'll just let you know in the meantime.
Okay.
Yes, if you build a good robot, we'll do offline. If you do a bad robot, you will do online.
Okay.
Okay. Go ahead.
Paris.
Thank you all. First of all, I would like to thank Professor Sunil Jha and SK Shah sir to give this opportunity to us to build a robot. It was my first experience also, and it was very good to teach you all how we have built this robot and how it has designed. So thank you so much for the opportunity. Thank you.
And thank you, Paras. And I would like to ask Pankaj.
Very good morning, good afternoon to all. And I'm giving thanks to Professor Saha and Professor Sunil Jha to giving us such a good opportunity. And it is also my first experience to serving you all. And I hope the things are going in a good manner. We will do next in a physical mode. Thank you. Thank you.
Yeah,
thank
please
you.
mute it. So thank you very much. So I would like to ask now Professor SK Saha sir to give his suggestions, comments, and wishes to all the participants.
Well, thank you. So मैंने तो कुछ किया ही नहीं है, पीछे पीछे बैठ के देख रहा था. But it's nice to see people have come forward, and special thanks to start with senior most Sunil and the whole team. I have never seen such a dedication in last 25 years of Robocon's preparation. So I think it's a great effort done. When I saw the PPTs made by Paras and the team, and all were so excellent, and extra effort taken by Sunil to conduct the program by Autodesk and other people. So it was almost like spontaneous. So I think our dream is coming true, that India is truly becoming tech savvy. It's not only IT savvy, tech savvy, and I hope for this momentum will continue, and possibly we might repeat such program even after Robocon, for the benefit of next year participants. So all the best for Robocon, and not only the students will participate, and I think we need their blessings or their good wish so that it can happen physically in a stadium where we have already planned. Thank you.
Thank you very much, sir. Now I'd like to ask Professor Sunil Jha, sir, to give his views, comments, and suggestions.
Yeah, so I think because I was just witnessing the activity last 3 days, we try to compensate what has not been done, being not conducting this physically actually. So our intent was basically to deliver even the similar experience as we could do in a physical mode. So through online also we have planned the sessions, we have planned the demonstrations in such a way that you will get more and more informations. That is the intent. The good thing is that we have prepared the base ourselves. That is how the Paras, Venkat, and then Pankaj is working. So the same experience will be brought out actually, the way it's supposed to be done. See, unless you do the thing, you cannot teach. That's a very important part. Whatever Color was demonstrating certainly has gone deep into the learning part on the ROS and the Tinkercad. Whatever mechanical fabrication has been done, Pankaj, Paras, and Venkat all have spent days and nights to build that platform. So what I just want to say that the more work you will do, learning is always basically once you keep doing the things. So whatever you learn, unless you implement, it will not help much. So idea behind the Robocon is this: you try to implement as much as your engineering learning in creating this kind of an hardware and the platform, which is certainly more interdisciplinary. Started with the mechanical, then electronics integration, and then the programming aspect. So that is what I always enjoy, working with the team who is dedicated and then would like to demonstrate the capabilities. And I always look forward that each one of you have a capability to build these kind of robots. Our intent is basically to give you a learning, and so that you can create a more robust platform. We would like to improve the designs of the robots in the Robocon, so that even this time we are going to host the international event as well. So the countries those who are coming to see, we should show them that we as an India also have a capability to build good robots. That was the intent, and certainly this is just a start of the whole sequence. We look forward to support you and interact with you as we go along at the various stages of the participation. So thank you so much. I would like to thank everyone in the team. Certainly, as Professor Saha has mentioned, such a kind of a dedication will only encourage you to do more such events. So thanks Venkat, thanks Paras, Pankaj, Kalar, Professor Saha to just come out with the idea of a boot camp, and we just execute that. Thanks everyone for that, and thanks all who participated in this event dedicatedly. Even for a longer sessions, I found the strength intact. That's a good indication, and then all of you have taken a good interest in the whole program. So thank you so much for this conducting this event successfully. Thank you.
So thank you very much. So before we conclude this boot camp on the final day, I would like to take this opportunity to thank all the sponsors of the main event and the expert sessions. So starting from Autodesk, Advert Technologies, MathWorks, and I thank FSM, the Foundation for Smart Manufacturing, and I have Foundation for giving a beautiful platform for us to come up with, and the Robocon organizing team and IIT Delhi for giving us this opportunity, and especially Doordarshan for covering this in the news. Thank you very much. So thanks.
What about a photo together?
Yes, come together. Yeah.
So let me
everybody
in gallery.
Smile. Yeah, and
Please
gallery.
switch on your cameras.
With a big smile. Switch on your lips also. Right. And then put everything in the Facebook, LinkedIn immediately after this.
Sure. So,
and see how many likes we get it.
Gauri and Sri Ranganathan, I would like to ask you to switch on your cameras. If you so, Paras, you also take some screenshots, okay? So, if possible, everyone, please take screenshots and put it on the WhatsApp group, okay? So, if may, yeah.
Smile, big smile.
Here we go.
Click, 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 click. Oh, yeah?
Yes.
Just a second.
Okay, now I can hear the sound. Okay, thank you all.
Thank you very much. Thank you very much.
Bye.
Take care.